Hello fellow sapiens, and welcome to Sleepless Homo. Take a moment to settle in, whether you're preparing to sleep, unwinding after a long day, or just letting your mind drift while cooking, showering, or working with headphones on. This channel is here for slow science and quiet storytelling. No hype, no wild speculation, just humble archaeology and careful history told softly. If you value this kind of long-form content, consider liking and subscribing. It helps others find their way to knowledge and maybe conquer the world with curiosity instead of noise. And if you'd like, share in the comments how you use these stories. Do you listen at night before bed, or during the day as you work? However you join us, know that if you drift off mid-chapter, I've placed timestamps in the description so you can pick up right where you left off, because the story is worth hearing all the way through. And as always, stay curious, stay calm. Tonight, we begin with the oldest migration into the Americas, a journey that rewrote the human map. Tonight, we begin with a question that lingers at the heart of history. Why does the story of the Americas so often begin far too late? In the average American classroom, history begins with the year 1492, when Columbus crossed an ocean and stumbled onto a continent that millions of people already called home. A year that became a shorthand rhyme for schoolchildren, a turning point that textbooks insist is the beginning of American history. Yet for those of us who have spent time with archaeology, genetics, and the traces of deep time, it is striking how shallow that entry point is. Tens of thousands of years had already passed. Whole civilizations had risen and fallen. Landscapes had been settled, abandoned, and settled again. The real beginning was not a European ship appearing on the horizon, but small groups of human beings, indistinguishable from us, finding their way into a vast unpeopled land at the edge of the world. The choice to start with Columbus is not simply a matter of chronology but of perspective. It centres the story on contact rather than origins, on written records rather than oral memory, on the perspective of one small corner of humanity rather than the global journey that carried all of us to every corner of the planet. It is a story compressed to fit the neat boundaries of nation-states and political events, but one that leaves out the greater adventure. And that adventure is the last chapter in the tale of human migration. Long after our species had walked out of Africa, long after we had settled Europe and Asia, long after we had even reached Australia by sea, the Americas remained the final frontier. Why then is this frontier so often erased? Part of the answer lies in evidence, or rather the lack of it. For much of the 20th century, the remains of early life in the Americas were scarce, hard to interpret and easy to doubt. Archaeologists struggled to agree on what was truly ancient and what was simply old. Sites that might have changed the story were dismissed as contaminated or misdated. In the absence of clarity, a convenient narrative held sway, the so-called Clovis first model. According to that model, people only arrived in the Americas around 13,500 years ago, just after the last ice sheets retreated, leaving behind their distinctive fluted spear points. It was a neat package, clean and seemingly logical. The problem was that it was wrong. Over time, the cracks began to show. Evidence from Chile, Canada, and the United States suggested people had been here earlier than the Clovis toolkit allowed. Bones with butchery marks, hearths with charcoal far older than expected, footprints fossilized in ancient lake beds. Each piece of evidence suggested that the story began much earlier. Yet the textbooks did not budge. The rhyme of Columbus endured. The story of first peoples remained in limbo, trapped behind professional skepticism and public indifference. What is at stake here is not simply a date on a timeline, but our understanding of who the first Americans were and how their arrival reshaped the world. Imagine for a moment the landscapes they encountered. North America, between 30,000 and 10,000 years ago, was home to a caste of animals that now seem almost mythical. Mammoths taller than houses, saber-toothed cats, giant ground sloths, dire wolves, beavers the size of bears. When humans entered these lands, they were not walking into an untouched wilderness, but into an ecological drama that had been unfolding for millions of years. Their presence would tilt the balance, sometimes subtly, sometimes catastrophically. To leave this out of history is to erase not just people, but entire worlds. There is another reason why the story of early America has been pushed aside. It is uncomfortable. It does not conform to tidy national myths. If people were here 15 or 20,000 years ago, then American history does not begin with European colonization or even with the rise of Mesoamerican empires, but with nameless bands of hunter-gatherers whose stories survive only in fragments of bone and stone. They did not leave monuments on the scale of Egypt or Mesopotamia. They did not write their names in stone. But they endured harsh climates, innovated and adapted. To study them is to acknowledge that our species has always been restless, always been moving, always been reinventing itself at the edge of survival. For decades, scientists argued bitterly about the earliest dates. Careers were built and destroyed on the acceptance or rejection of a handful of sites. Some researchers who dared to publish evidence of a pre-Clovis presence were ostracized, accused of sloppiness or quietly ignored. And yet slowly the tide shifted. Better dating methods, more careful excavations and advances in genetics gave weight to the idea that people had been here much longer than once assumed. The neat story of Clovis first began to unravel, and in its place grew a messier, richer, more human story. To start history at Columbus is to miss that story. To start history at Clovis is to cut it short by thousands of years. The truth, as best as we can see it now, is that people entered the Americas at multiple times, in multiple ways, long before the textbooks admit. Some groups may have come by sea, hugging the Pacific coast in small boats. Others may have walked through temporary corridors when the glaciers retreated. Some migrations may have failed, leaving no living descendants. Others succeeded and flourished. The peopling of the Americas was not a single event, but a long process, filled with false starts and forgotten paths. This matters because it changes how we understand ourselves. If we begin with Columbus, then history is a story of conquest and contact. If we begin with Clovis, then it is a story of hunters chasing mammoths across a melting ice age. But if we begin with the earliest arrivals, 20 or even 30,000 years ago, then history becomes a story of human persistence at the edge of possibility. It becomes a story not of sudden discovery, but of gradual settlement, of resilience, of adaptation to some of the harshest conditions on Earth. And this is not just academic hair-splitting. The story we tell about beginnings shapes how we think about everything that follows. If the Americas were only populated late, then their indigenous peoples are framed as recent arrivals, almost temporary tenants. But if their roots go back tens of thousands of years, then they are among the oldest continuous cultures on the planet. That distinction matters, not just in classrooms, but in politics, in identity, in how societies value heritage. What we know so far is still incomplete. Archaeology is a patient science, and every new site discovered may rewrite what we thought we knew. Scientists, when they are honest, will tell you that they do not have all the answers. What we have are fragments, signals from the deep past, stitched into a story that is always provisional. But even with those fragments, the outline is clear. The real history of the Americas does not begin in the 15th century, nor in the 13th millennium before present. It begins much earlier, with people whose names we will never know but whose footprints, bones and tools remind us that they were here, living, struggling, imagining. So the haunting question lingers. How much earlier did it begin, and how many chapters have already been lost to time? If textbooks one day start the story in the deep past, will we finally see the Americas not as a land discovered late, but as a land always waiting and eventually found by people who are already like us in every way that matters? What global journey did humans already complete before turning toward the Americas? To understand why the story of the first Americans matters, we need to step back and recognize the path that had already been traveled by our kind long before anyone set foot in the New World. The Americas were not the first frontier, they were the last. For tens of thousands of years before that final crossing, humans had been moving outward from their birthplace in Africa, spreading across continents, adapting to landscapes as different as tundra and desert, and carrying with them not only tools but languages, ideas, and social worlds. By the time small groups eventually found themselves near the edge of Siberia, staring across toward a continent they could not yet see, their species had already achieved something astonishing. They had gone from a local primate to a global presence. The journey begins in Africa. Fossil and genetic evidence suggests that our species, Homo sapiens, emerged there roughly 300,000 years ago. For a long stretch of prehistory, our ancestors remained primarily within Africa, experimenting with stone tools, learning to hunt and gather in increasingly complex ways, and enduring the environmental swings of Ice Age cycles. But by about 100,000 years ago, we start to see hints of movement beyond the continent. Fossils from the Levant, in what is now Israel and Lebanon, show that modern humans were pushing into the margins of Eurasia. Some of these early forays may not have lasted, with populations retreating back into Africa as climates changed. But the impulse was there. The decisive expansion came later, around 70,000 to 60,000 years ago, when genetic data suggest a major dispersal of humans out of Africa. This movement was not a single heroic march, but likely waves of small groups, following coastlines, rivers and grasslands, moving slowly but persistently. Archaeology shows their presence in Arabia, India and Southeast Asia. By 50,000 years ago they were in Australia, which could only have been reached by sea, even in an Ice Age world with lower sea levels. This alone is a staggering thought. Long before ships, long before written records, small groups of humans had learned how to build watercraft sufficient to cross tens of kilometres of open water. It was not an accident. It was knowledge passed down and refined. These dispersals were not just about geography, they reshaped the human family tree. As modern humans spread into Eurasia, they encountered other hominins, Neanderthals in Europe and parts of Western Asia, Denisovans further east, and perhaps other archaic populations not yet fully known. The evidence now shows that these encounters were not simple replacements. They involved interbreeding. All non-African people alive today carry traces of Neanderthal DNA, and some populations in Asia and Oceania carry Denisovan ancestry. This blending reminds us that our story is not one of pure lines, but of tangled roots. By 45,000 years ago, modern humans were firmly established across Europe. Sites in places like Romania and Italy preserve the remains of early Europeans who were already crafting ornaments, symbolic art and specialised hunting tools. In Siberia, humans had moved into cold environments, following herds of mammoth and reindeer. In East Asia, they adapted to river valleys and forests, with archaeological finds in China pointing to a diversity of stone tool traditions. By 40,000 years ago, the human footprint was global in scope. Our species had spread across 3 continents and had already demonstrated a capacity to live in extremes, from tropical rainforests to subarctic plains. Australia deserves special mention. The colonisation of 𝐓𝐈𝐌𝐿𝐿, the ancient landmass that included Australia and New Guinea, marks one of the boldest steps of early humans. To reach it, people had to cross a series of water gaps in what is now Indonesia. The voyage was not a matter of drifting. It required planning, coordination, and an understanding of tides and currents. Once there, humans adapted to a continent filled with marsupials, giant birds, and ecosystems utterly unlike those of Africa or Eurasia. Archaeological sites like Lake Mungo in southeastern Australia preserve evidence of human occupation at least 40,000 years ago, with burials and artefacts that testify to symbolic behaviour. The point of all this is that by the time humans ever considered reaching the Americas, they were already a species that had proven its ability to conquer distance, to adapt, and to survive in new worlds. They had walked into Europe, sailed into Oceania, and endured the harsh winters of Siberia. They were not wanderers without purpose. They were explorers in the deepest sense, responding to climate shifts, following herds, seeking new resources, and sometimes simply moving because that is what our kind has always done. We sometimes think of migration as a unique event, but the truth is that migration is the defining characteristic of our species. Humans have always been on the move. Archaeologists talk about out of Africa as though it were one event, but in truth it happened again and again. Some early expansions may have failed, leaving no descendants. Others succeeded, planting roots that remain in the genomes of people alive today. The story of leaving Africa is not a straight line, but a series of waves, each shaped by environment, chance, and human resilience. This long prelude also puts into perspective the idea of the Americas as the last great frontier. When we think of people crossing into the New World, it is easy to imagine it as a singular, extraordinary feat, and it was extraordinary, but it was not unprecedented. By the time humans reached the far edges of Asia, they had already accomplished feats that proved such a crossing was possible. They had faced ice, deserts, mountains, and oceans. They had outlived and outcompeted other hominins. They had filled the ecological niches of 3 continents. The Americas were simply the final space left unpeopled. And yet, what makes this moment so haunting is that the evidence is patchy and our understanding is incomplete. We know people left Africa. We know they spread far and wide. But the precise routes, the exact timing, the identities of the groups are still debated. Did they hug coastlines, fishing and foraging as they went? Did they move inland along rivers and grasslands? Were there multiple pulses of expansion, some of which left no trace? These are questions that scientists wrestle with, and honest answers admit uncertainty. We can say what seems likely, but we cannot claim absolute certainty. When we look at the big picture, the Americas stand out as the last blank on the map. By 40,000 years ago, humans had reached Australia. By 30,000 years ago, they had spread deep into Siberia. Everywhere else had been touched. The Americas remained isolated, a vast ecological continent filled with creatures that had never seen humans. The stage was set, the actors were ready, but the crossing had not yet occurred. So the haunting question is this: if our species had already proven its ability to adapt, to travel, and to thrive in every other corner of the globe, why did it take so long to reach the Americas? Was it geography, with ice and oceans forming barriers? Was it chance, with no groups happening to make the journey until later? Or were there earlier crossings, now lost to time, migrations that failed or left no genetic legacy? The story of walking out of Africa again and again reminds us that our past is not a simple triumphal march. It is a record of persistence, failure, resilience, and mystery. And when we finally turn to the Americas, we carry with us that broader story of a species that has always been in motion, always searching for what lies beyond the horizon. To ease our way into this part of the story, it helps to imagine the world map not as a fixed picture, but as a shifting set of thresholds. Every boundary that humans faced was at first a barrier: the Sahara Desert, the Himalayan mountains, the rivers of Southeast Asia. Each one seemed impassable until in time it was crossed. The slow outward spread of our species is less about bold leaps and more about a pattern. Small groups following the resources in front of them, gradually extending the edge of what they knew. This is how Africa became Eurasia, how Eurasia became Oceania, and eventually how one distant day Siberia would become the gateway to a whole new hemisphere. This wider journey also reminds us that humans were not unique in moving outward. Animals were spreading too, shifting their ranges in response to climate, tracking vegetation and prey. The difference was that humans carried something extra: culture. Knowledge was passed down, tools refined, languages adapted to new environments. Culture acted like a second inheritance, allowing each generation to begin not from zero but from the accumulated experience of those before. When people reached new landscapes, they did not just survive by instinct. They survived by memory, by tradition, and by experimenting with what worked. That, more than muscle or speed, was the secret to why our ancestors could spread so widely. By the time small groups stood on the frozen margins of northern Asia, looking eastward toward what they could not yet know was another continent, they were already the inheritors of this long chain of dispersals. The Americas were not an isolated miracle. They were the final act in a play that had been rehearsed across deserts, forests and oceans for tens of thousands of years. Who were the ancient North Siberians, and how did they survive at the top of the world? This question leads us into one of the most remarkable and least expected discoveries in recent archaeology, a reminder that our species has always been able to push into environments that seem, at first glance, impossible for survival. For a long time, scientists assumed that humans only reached the high Arctic much later in prehistory, long after the last glacial maximum. It was thought that the cold, the long winters without sunlight, and the scarcity of resources would have formed a natural barrier. Yet evidence along the Yana River in Siberia tells a very different story. Here, more than 30,000 years ago, people were already living above the Arctic Circle, adapting to the harshness of that world, and leaving behind traces of a life that was both practical and surprisingly rich. The Yana rhinoceros horn site, named for the remains of woolly rhinoceros found there, sits on the banks of the Yana River in northeastern Siberia. When it was first excavated, Archaeologists were astonished at what they found. Not only were there animal bones and stone tools, but also ornaments, ivory carvings, and evidence of structured activity that showed this was no fleeting campsite. This was a place where people lived, hunted, and imagined. 2 human teeth were eventually recovered, belonging to young individuals. From these, scientists were able to extract genetic material that revealed the existence of a population now called the ancient North Siberians. They had branched off from East Asians tens of thousands of years earlier, forming a distinct lineage that would later mix with others to form the ancestors of Native Americans. To survive in that environment required more than simply toughness. It required ingenuity. The Yana River region would have been brutally cold, with temperatures dropping far below freezing for much of the year. The winters would have brought long stretches of darkness, and yet people stayed. They hunted mammoth, rhinoceros, horse, reindeer, and bison. Animals that themselves were adapted to the Ice Age steppe. They likely used the hides and furs of these creatures for clothing, and their bones and ivory for tools. Archaeologists have found needles with drilled eyes from this period, suggesting that tailored clothing was already being made. Without such clothing, survival in these conditions would have been impossible. What is striking about Yana is not just the fact of human presence, but its scale. The site shows signs of repeated occupation, of a community that may have numbered in the hundreds. This was not a solitary group eking out a living. It was a viable society, one that had found ways to endure and even to thrive in a place once thought uninhabitable. The presence of ornaments and personal items suggests that they were not living lives of constant desperation. They had the time and the will to create, to decorate, to mark meaning onto their world. This reminds us that human adaptation is not only biological but cultural. People can find warmth in ritual and resilience in shared stories as much as in the hides of the animals they hunt. Genetic analysis of the Yana teeth has opened a window into deep population history. It shows that the ancient North Siberians were a separate branch, distinct from both Europeans and East Asians, yet connected to them through earlier ancestry. This matters because it shows that humans had spread into the far north earlier and more extensively than previously assumed. The Arctic was not a barrier but a home, and that home became a crossroads. Over the next several millennia, groups like the ancient North Siberians would encounter and mix with other populations, creating the genetic foundation for later peoples of the Americas. Without their presence, the migration story of the New World would look very different. We should pause here to recognise how much this discovery changes our mental map of prehistory. To think of humans at 30,000 years ago, already carving ivory, and leaving ornaments in a place where the sun vanishes for months, is to confront the resilience of our species. We often underestimate the capabilities of early humans, imagining them as marginal, desperate, barely surviving. The Yana site challenges that image. It shows planning, adaptation, and symbolic life at what was then the edge of the known world. The environment itself, often called the Mammoth Steppe, was a unique ecosystem stretching across much of northern Eurasia. It was not the barren wasteland we might imagine, but a cold grassland rich in large herbivores. Mammoth and woolly rhinoceros were part of this ecosystem, as were steppe bison and reindeer. Humans were part of this system too, hunting, scavenging, and shaping the landscape through fire and movement. The ability to exploit this ecosystem may have given them the skills needed to eventually move further east, into lands that led closer and closer to the Americas, yet much remains unknown. We have only a few sites like Yana. How widespread were these ancient North Siberians? How many other camps and settlements now lie buried under permafrost or lost to erosion? What languages did they speak? What myths did they tell? How did they organise their societies? The archaeological record cannot answer these questions fully. All we have are fragments, a carved piece of ivory, a needle, a tooth. From these, we try to imagine entire lives. The haunting question, then, is whether these people ever looked eastward and wondered what lay beyond. At that time, the world was colder, seas were lower, and lands that are now drowned by the Arctic Ocean may have been dry and habitable. Did groups of ancient North Siberians venture into those lands, long before the more widely known migrations? Were there attempts that failed, communities that lived for a time and then vanished without leaving descendants? It is possible. Archaeology often gives us the story of those who succeeded, but behind it there may be countless forgotten journeys. The Unna River site reminds us that by 40,000 to 30,000 years ago, humans were already testing the limits of where they could live. They had conquered deserts, mountains, and forests, and now they had conquered the high Arctic. The final frontier of the Americas still awaited them, but the skills, the endurance, and the imagination needed to cross it were already in place. The ancient North Siberians in their cold camps along the Yana were part of that preparation. They may not have known it, but they were setting the stage for one of the greatest human journeys of all. And so, the question lingers. How many other forgotten peoples lived and died at the edges of the map, their stories reduced to a few bones and tools, their names lost forever, but their presence essential in shaping the migrations that followed? Before we turn fully toward the people of the Unna River, it is worth pausing to consider how extraordinary it is that anyone reached such latitudes at all. Human beings are, at their biological core, tropical creatures. Our physiology evolved in warm environments, and compared to other animals of the north, we lack fur, we lack layers of fat, we lack claws or natural insulation. What carried us into colder regions was not our bodies, but our ability to reshape the world around us. Fire provided warmth and light, clothing provided shelter from wind, and social cooperation allowed groups to share food and knowledge. Every move further north was a gamble, but one backed by these cultural tools. As humans pressed into Eurasia, the steppe became both a highway and a proving ground. Vast herds of grazing animals could be followed for hundreds of kilometres, offering meat, hides, and bone. The open landscapes allowed visibility, but they also demanded mobility and planning. To thrive here, groups had to know the movements of animals, anticipate seasonal changes, and prepare stores for the leanest months. It was this constant practice of adaptation that eventually brought them into the realm of permanent snow and permafrost. The archaeological record shows that these expansions were not random wanderings. Campsites appear near rivers, on ridges, in places where resources were most concentrated. Tools were shaped with care, reflecting knowledge passed down and refined. By the time humans reached northeastern Siberia, they had been honing these strategies for tens of thousands of years. The surprise is not that they reached the Arctic, but that we once doubted it. And so, when evidence from Yana appeared, showing a population well established above the Arctic Circle 30,000 years ago, it was less a revelation than a reminder of what humans had already proven capable of. These people were not anomalies. They were the inheritors of a long trajectory of persistence. Their lives may have been hard, but they were not impossible. The skills and the mindset that carried them north would one day help carry others further still, toward a continent waiting silently beyond the ice. What happens when two long-separated populations meet again during the harshest ice age? The answer lies not in monuments or stone tools, but in the invisible threads of DNA, preserved in the bones of long-dead children and the genomes of people living today. Around 25,000 years ago, in the depths of the Last Glacial Maximum, two human lineages, one that had branched off into the far north of Siberia, and another that had lingered further south in East Asia, came together once more. Their meeting produced a new population, one that carried a mixture of both ancestries and would, over time, become the foundation for all later peoples of the Americas. This event is often described in shorthand as the genetic collision, but in truth it was a quiet and human moment, a merging of families and communities who may never have imagined the legacy they were creating. Geneticists can trace this meeting because the DNA of modern Native Americans carries signatures of both these ancestral groups. The ancient North Siberians, who had endured life above the Arctic Circle for millennia, contributed one part of the heritage. The East Asians, who had remained closer to temperate regions, contributed another. Alone, neither of these lineages matches the genetic profile of later indigenous peoples. Together they do. The mixture seems to have taken place at or just before the peak of the last ice age, when glaciers expanded, climates dried, and survival became ever more precarious. It was a time of bottlenecks, when human populations shrank to small sizes and isolation became the norm. Yet in some corner of northeastern Asia, people met, exchanged partners, and wove their bloodlines together. What makes this especially fascinating is that the evidence comes not just from living populations, but from ancient remains. At the site of Malta near Lake Baikal, a burial of a young boy who lived 24,000 years ago has been studied in detail. His genome shows a mixture of affinities. On one side, links to populations of Western Eurasia, on the other, genetic elements that later appear in Native Americans. He was not an ancestor in the direct sense of a family tree, but his DNA provides a glimpse of the kinds of people present in Siberia at the time, blending ancestries and passing them forward. When scientists compare his genome to others, they see echoes of this mixture repeated, a pattern of fusion that would echo across continents. The context for this meeting is important. The Last Glacial Maximum was not a single uniform freeze but a series of climatic shifts that reshaped habitats. Vast ice sheets locked up water, lowering sea levels and exposing new lands, while simultaneously cutting off routes across northern continents. In Eurasia, deserts expanded, forests shrank, and grasslands turned brittle. Populations were pushed into refugia, places where conditions remained survivable. In East Asia, river valleys may have provided such havens. In the north, steppe environments still supported mammoth, bison, and reindeer. Somewhere at the margins, groups from these regions encountered one another. We cannot know exactly what those encounters looked like. Perhaps it was the gradual intermarriage of neighbouring bands, exchanging daughters and sons as humans often did to form alliances. Perhaps it was the absorption of a smaller group into a larger one after a period of hardship. The genetic data cannot tell us the stories of individuals, but it can show us the outcome, a blended population that carried new genetic signatures. Over the following millennia, these people would remain isolated in the vast northeast, cut off from further contact with their Asian relatives, developing a distinct genetic identity. This period of isolation is what scientists call the Beringian standstill. The standstill is not a metaphor but a measurable reality. Genetic studies suggest that after this fusion event, the ancestors of Native Americans were cut off from the rest of Asia for thousands of years. Their DNA began to drift, accumulating changes unique to them. The population may have been small, perhaps only a few thousand individuals, yet it endured. While climates shifted and ice sheets waxed and waned, these people held on in their refuges. When the time came, long after, for some of them to move east into the Americas, they carried with them not only their cultural knowledge, but the imprint of this genetic history. What is striking about this story is how much it alters our understanding of migration. For decades, the image was simple. One group of people crossed into the Americas, but the genetic evidence shows that it was not one group, but the descendants of a fusion, a population born of survival and mingling during one of the harshest climatic episodes in human history. The ancestors of Native Americans are not a branch off a single Asian population. They are a braid, woven from strands that had separated long before and then rejoined in the cold. This understanding also reshapes how we think about identity. Too often, discussions of ancient populations are framed in terms of purity, of single origins. The reality is more complex. Human history is a record of mixing, of populations coming together, sometimes willingly, sometimes under duress, and creating something new. The ancient North Siberians and East Asians did not remain apart. They merged, and their descendants became the first peoples of a hemisphere. Without that blending, the later chapters of human history in the Americas would not exist. Still, much remains uncertain. The exact location of the meeting is debated. Was it in the Lake Baikal region, where the Malta boy was buried? Was it closer to the Lena River, deeper in the Siberian steppe? Or was it further east, near the lands that once connected Asia to Alaska? Archaeology alone cannot yet resolve this. The sites from this period are rare, and preservation is uneven. Genetic data provide broad patterns but not precise maps. What we can say is that by 25,000 years ago, the fusion had occurred, and by the end of the Ice Age, the population born of it was ready to expand. One of the humbling lessons here is that our knowledge is stitched together from fragments. A tooth from Yana, a burial from Malta, the DNA of modern communities, all of these serve as threads. From them, scientists weave hypotheses, always provisional, always open to revision. The story of the genetic collision is not finished. As new remains are found and new genomes sequenced, the details will sharpen, and perhaps new surprises will emerge. For now, what we can see is a moment in which humanity, pressed by cold and scarcity, did what it has always done. It came together, it formed bonds, and it endured. The haunting question is this: how many other collisions like this took place, unseen and undocumented, in the deep past? How many lineages were born and lost? How many mixtures vanished without leaving a trace? The ancestors of Native Americans are remembered because their descendants crossed into a new continent and survived. But for every remembered fusion, there may be dozens that ended in silence. Our story, as far as we can reconstruct it, is both a tale of continuity and of erasure. The genetic collision in the cold stands out because it left a legacy that continues today. But it reminds us that most of human history is a record of disappearances as much as arrivals. The image of this collision of lineages also reminds us that migrations are not always about movement across open land, but about what happens when survival pressure pulls groups into the same shrinking refuge. The Last Glacial Maximum did not create opportunities so much as it closed them off. Forests receded, rivers froze, and grasslands narrowed into patches of steppe where herds could still graze. In these compressed spaces, people who had once diverged may have found themselves neighbours again, forced into proximity by climate rather than curiosity. When landscapes shrink, human diversity can collapse into pockets, and those pockets become laboratories of genetic exchange. This is not the first time our species had undergone such a bottleneck. Genetic studies of populations in Africa suggest earlier episodes, when drought or volcanic eruptions reduced numbers dramatically, leaving only small clusters of survivors to repopulate regions later. Each time, what looked like fragility was also a crucible for resilience. The ancestors of Native Americans emerged from just such a crucible in Siberia. We do not need to imagine large migrations sweeping majestically across ice sheets. It may have been as simple as a few extended families wintering in the same valley, sharing hunting grounds, and slowly merging across generations. From this vantage point, the standstill that followed is less a pause and more a gestation. For thousands of years, this mixed population endured isolation. They could not easily return south because ice sheets and deserts blocked the way. They could not yet push east into the Americas because glaciers closed that path too. Instead, they waited, unintentionally, perhaps unknowingly, while their genetic distinctiveness crystallized. What later scientists call the Beringian standstill might, for the people themselves, have felt like nothing more than ordinary life. Hunting, raising children, exchanging knowledge, telling stories around fires. Yet in the long arc of human history, this quiet endurance was decisive, and it leaves us with an uneasy thought. How many other populations were caught in such standstills, isolated for centuries or millennia, only to vanish without a trace? The ancestors of Native Americans were fortunate in that their isolation ended with a new beginning. Others may have waited just as long, only for the ice or drought to erase them completely. Was Beringia simply a crossing, or a homeland in itself? For decades, the land bridge between Siberia and Alaska was imagined as little more than a strip of frozen earth, a bleak causeway that humans dashed across on their way to more promising lands. But the evidence suggests something far richer and more complicated. What we call Beringia was not just a bridge. It was a world of its own, stretching thousands of kilometres from the Lena River in eastern Siberia to the Mackenzie River in what is now Canada, a place where humans, animals and plants could thrive for millennia. To understand the settlement of the Americas, we must pause here and recognise Beringia not as an incidental crossing, but as a landscape that shaped the very people who would one day move beyond it. During the period between 30,000 and 20,000 years ago, global sea levels were far lower than today. Vast amounts of water were locked up in glaciers, and the shallow seafloor of the Bering Strait lay exposed. What had once been an ocean channel became an expanse of tundra, steppe, and wetlands. Paleoenvironmental studies reconstruct Beringia as a patchwork of habitats, not the barren wasteland one might expect. Coastal areas, particularly in the south, offered marshes and estuaries rich in fish, waterfowl and edible plants. Inland, the so-called mammoth steppe supported grazing herds of bison, reindeer, horse and mammoth. In some regions, shrubs and trees grew in sheltered valleys, providing wood and berries. The climate was cold, yes, but it was not empty. For human groups used to adapting to extremes, Beringia may have been less an obstacle than an opportunity. Imagine small bands moving into this landscape, discovering not only animals to hunt but fish to catch, reeds to weave, berries to gather. Archaeologists have long debated whether people could truly live in such an environment year-round, but the ecological reconstructions suggest it was not only possible, but sustainable. Indeed, some scholars propose that populations remained in Beringia for thousands of years, cut off from Asia by glaciers to the west, and from the Americas by ice sheets to the east. This so-called standstill created a population incubator, where genetic traits became distinctive and cultural practices took root. We often speak of migration as if it were a sprint from one destination to another, but human history shows that pauses are just as important as movements. For those who lived in Beringia, this was not a temporary campsite. It was home. Here children were born, fires burned, and lives unfolded. Even the very concept of crossing may have made little sense to them. They did not know they were standing on a vanished seafloor. They knew only that this was land, habitable and sustaining. In that sense, Beringia was not a bridge but a country, one that existed for thousands of years before being swallowed again by rising seas. Archaeological traces of this homeland are difficult to recover. Much of central Beringia now lies beneath the Bering Strait and the Chukchi and Beaufort seas, drowned when the glaciers melted and the waters rose. What remains on the margins are tantalizing fragments: butchered bones, stone tools, traces of human activity along the Alaskan side or in northeastern Siberia. Sites like Bluefish Caves hint at the antiquity of human presence in this wider region, though debates continue over their interpretation. The absence of evidence in central Beringia is not evidence of absence. It is simply the reality that much of the best land for early humans now lies under icy waters. Environmental modelling has suggested that southern Beringia, along the Pacific coast, may have been especially rich. Warmer currents and kelp forests would have supported a wide range of marine life: seals, fish, seabirds, and shellfish. Archaeologists sometimes refer to this as the Kelp Highway, a corridor of productivity that stretched along the Pacific Rim from Japan to California. If people were already using boats and exploiting marine resources, as evidence from Australia and the Channel Islands suggests, then Beringia's coasts would have been ideal stepping stones. The idea that humans clung to river mouths and shorelines is not fanciful. It is entirely consistent with what we know of human behaviour elsewhere. Meanwhile, the northern plains of Beringia were dominated by the great herbivores of the Pleistocene. This was the realm of mammoths, woolly rhinoceros, and bison. For hunters with stone-tipped spears, such animals represented both immense opportunity and danger. To take down one mammoth could feed a community for weeks, but the risks were obvious. The bones of these animals scattered across the permafrost testify to an ecosystem of abundance, not desolation. Humans who learned to master this step could endure some of the harshest conditions on Earth. What makes Beringia especially compelling is that it was both a crossroads and a cul-de-sac. To the west lay ice and distance, to the east lay glaciers and barriers. Populations who entered may have found themselves effectively penned in for centuries. Rather than imagining people hurrying across, we should picture generations living their entire lives without ever leaving. It was in these long winters and short summers that the genetic distinctiveness of the first Americans crystallized. It was here that survival strategies hardened into traditions. Still, uncertainties abound. We do not yet know precisely when people first occupied central Beringia. Some genetic models suggest arrival before the last glacial maximum, others closer to its peak. Archaeology has yet to catch up, largely because the best evidence lies under the sea. What we can say is that Beringia was not an empty bridge but a populated world. It shaped the people who lived there, and in turn, those people would shape the history of the Americas. The haunting question, then, is how much of that world is now lost. Beneath the waves of the Bering Strait lie the camps, hearths, and pathways of entire generations, a sunken homeland erased by time. We know it existed, we know it mattered, but we may never fully recover its story. What fragments we do find on the edges, bones, tools, a few strands of DNA, are enough to remind us that the ancestors of the first Americans did not simply pass through Beringia. They belonged to it. If we think of Beringia not as a bridge but as a lost continent, its role in human history becomes clearer. This was not a narrow corridor, but a landmass the size of modern Western Europe, complete with mountains, rivers, coastlines, and ecological zones as varied as tundra, grassland, and marsh. For the people who lived there, it was not a temporary crossing, but the centre of their universe. They would not have known that the land beneath their feet was borrowed time, destined to drown beneath rising seas. They would have known only that the reindeer migrated in predictable cycles, that salmon returned to the rivers, and that driftwood could be gathered along the shore. The very scale of Beringia also suggests cultural diversity. Populations scattered across such a vast area would not have been a single monolithic group. Communities on the northern plains may have built their lives around the pursuit of mammoth and bison, while those in the south exploited marine resources along the kelp-rich coasts. Even within inland valleys, strategies could have differed depending on the mix of vegetation, water, and animal herds. This mosaic of microenvironments almost guarantees a mosaic of cultures. Yet because so much of Beringia now lies submerged, we see only the faintest outlines of this lost diversity. There is another reason to see Beringia as more than a bridge: time. The genetic and environmental evidence suggests people may have remained here for thousands of years, perhaps longer than the entire span of a later recorded history in some civilizations. Generations were born, grew old, and were buried in this land. To describe it merely as a crossing is to flatten the lived experience of countless families who saw no need to cross at all. For them, Beringia was simply home. When we look at the maps of submerged coastlines, we are reminded of how much human history lies hidden underwater. Just as Doggerland once connected Britain to Europe, and Sunda once connected Southeast Asia to its islands, Beringia was a continent that nurtured life and then vanished. The story of the Americas cannot be told without it, and yet we may never truly know the depth of what was lost beneath the waves. What does it mean for a people to be genetically frozen for thousands of years? The phrase might conjure images of bodies trapped in ice, but in truth it describes something subtler and stranger. Between 20,000 and 15,000 years ago, the ancestors of the first Americans were confined in Beringia, the vast landmass that connected Siberia to Alaska. Here, climate and geography formed a cage. To the west, ice and desert cut off return paths into Asia. To the east, the immense Laurentide and Cordilleran ice sheets blocked any route into the Americas. This isolation produced what geneticists now call the Beringian Standstill, a long pause in which a small population endured, drifted, and began to take on a genetic signature that separated them from all other humans on Earth. When geneticists look at the DNA of modern indigenous peoples of the Americas, they see traces of this standstill. Mutations that occurred in those long centuries became fixed, carried by every later descendant. The story is not one of stasis in the literal sense. People continued to live, marry, hunt, raise children, but their gene pool was sealed off. Unlike larger populations that could absorb newcomers and exchange partners across wide regions, this group was cut off. In such circumstances, genetic drift takes over. Random changes in the frequency of genetic variants, amplified by small numbers, shape the lineage. What we call the ancestral Native Americans are, in large part, the product of this deep freeze in Beringia. The archaeological record for this period is sparse, largely because the heart of Beringia now lies underwater. Yet the genetic signal is clear enough to show that at least two distinct lineages formed during the standstill. One branch became the ancestors of all later Native American populations south of the ice sheets. Another branch, known in the literature as the ancient Beringians, diverged but eventually left no direct modern descendants. Ancient DNA recovered from the Upward Sun River site in Alaska captures this ghost lineage. The burial of two infants there, dating to about 11,000 years ago, revealed a genetic profile distinct from later Native Americans. These children represent a people who had split off during the standstill, survived for millennia, but whose line ultimately faded. Their existence is a reminder that not every branch persists. The notion of being genetically frozen raises an uncomfortable truth about human history. We like to imagine progress as forward movement, as expansion. Yet here was a people confined for thousands of years, hemmed in by forces they could not control. Their endurance itself was an achievement. In the face of an unforgiving climate, They maintained social networks, passed down knowledge, and developed survival strategies. Tailored clothing, fire-making, shelters built from bone and hide, these were not luxuries but necessities. What we cannot yet see, though it must have existed, is the cultural life, the stories, rituals, and meanings that gave shape to their days. The Standstill was not unique in the broad sweep of human history. Other populations in other times have been caught in similar bottlenecks. What makes this one so significant is its legacy. The genetic drift that occurred in Beringia did not stay locked in that frozen land. When the ice sheets eventually retreated and the descendants of this population moved south, they carried with them the distinctive genetic markers of their time in isolation. Today those markers can still be found across the Americas, linking indigenous peoples from the Arctic to Patagonia back to those centuries of confinement. And yet, we should resist the temptation to see this as a simple prelude to migration. For the people themselves, Beringia was not a waiting room. It was home. Children were born and grew old there. Entire generations lived and died without ever knowing that their descendants would move beyond the ice. If we could speak with them, they might not recognize the concept of a standstill at all. To them, life continued as it always had, shaped by the hunt, the seasons, and the fragile balance of survival. The label is ours, not theirs. The haunting question is how many other human populations endured such isolations, shaping themselves in hidden corners of the world, only to vanish without leaving traces we can recover. The Beringian Standstill is visible because it left descendants who carried its genetic imprint into new lands. But others may have disappeared entirely, their stories erased by extinction, their names unrecorded. Our knowledge comes not from certainty but from fragments, pieced together with humility. All we can say for now is that in the frozen heart of Beringia, between 20,000 and 15,000 years ago, a small population of humans endured against the odds, and in their endurance they became something new. To understand the significance of the Beringian Standstill, it helps to imagine the world as it looked 20,000 years ago. Global sea levels were more than 100 meters lower than today. Vast glaciers dominated northern latitudes, and much of the planet's water was locked in ice. For humans, this meant compression. Landscapes that had once been open pathways became impassable, while corridors of survivable habitat narrowed. In Asia, deserts expanded, and in Europe, the advance of ice sheets forced populations into southern refuges. In northeastern Siberia and Alaska, however, the exposed floor of the Bering Strait offered a different sort of refuge. Not lush or easy, but relatively stable, with grazing herds, fish-filled rivers, and coastal marshes. Into this setting, a small population of humans settled, isolated from the rest of the world. Their isolation was not a matter of choice, but of geography. The frozen deserts of Siberia to the west and the impenetrable glaciers of North America to the east cut them off from broader networks. For perhaps thousands of years they lived in this enclosed world, and in that time their genetic profile slowly shifted. Isolation, after all, is a force of its own. It reduces variation, magnifies chance, and hardens the imprint of random mutations. The Standstill was not stillness. It was generations of ordinary life. But on the genetic level, it produced a unique signature that is still visible today. This idea of isolation shaping identity is something we see echoed elsewhere in prehistory. Populations stranded on islands, cut off by deserts, or hemmed in by mountains often develop distinctive traits, both biological and cultural. In Beringia, the same principle applied. People who had once been part of broader Asian networks became distinct. By the time the ice finally relented and passages opened, their descendants were no longer the same as those they had left behind. They carried with them a unique combination of ancestries forged during earlier Siberian encounters, sharpened and fixed by the long bottleneck of the Standstill. For archaeologists and geneticists, this period remains frustratingly elusive. We know it happened, but we cannot yet paint it in detail. Central Beringia, the heart of this refuge, lies beneath the modern Bering Sea. Campsites, hearths, discarded tools, and perhaps even burials are hidden underwater. What little survives is found at the margins, on the Alaskan side or in far eastern Siberia. From these scattered traces and from the DNA of later descendants, We infer a population that endured without contact for centuries. It is a reconstruction stitched from absence as much as presence. Still, the implications are profound. Without the Standstill, the story of the Americas would not exist in the form we know it. It was in this crucible of isolation that the genetic heritage of indigenous peoples took shape. Every person south of the ice sheets in later millennia carried echoes of those Beringian ancestors. Their endurance ensured that when the world finally opened, humans were ready to move into a new hemisphere. The haunting part of this story is not just what we know, but what we cannot recover. How did these people view their world? Did they imagine themselves trapped? Or was Beringia simply home, the only reality they knew? What kinds of songs or rituals gave meaning to the long winters? We cannot answer these questions with certainty. All we can say is that they endured, and in their endurance they preserved a lineage that would one day spread from the Arctic tundra to the southern tip of South America. When we think of the Beringian Standstill, then, it is not as a blank pause in history, but as a crucible of transformation. The genetic imprint of those isolated millennia is still alive in millions of people today. It is a reminder that sometimes the most decisive chapters of human history are not the moments of dramatic movement, but the long, quiet stretches when people simply held on. Could anyone possibly have crossed when North America was locked under kilometres of ice? To even pose the question is to confront the sheer scale of the obstacles that lay in front of the first Americans. During the height of the Last Glacial Maximum, around 26,000 to 20,000 years ago, the northern half of the continent was buried beneath two immense ice sheets. The Laurentides stretched from the Atlantic seaboard to the Central Plains, covering what is now New England, the Great Lakes, and most of Canada with ice more than 3 kilometres thick. To the west, the Cordilleran ice sheet sprawled over the Rocky Mountains, extending into modern Alaska and British Columbia. Together, these frozen walls fused into a continuous barrier spanning thousands of kilometres. For any humans trying to move south from Beringia, the effect was absolute. A continent locked behind walls of ice. It is difficult for us to visualise the enormity of these glaciers. Imagine the entire skyline of a modern city swallowed by white cliffs that never end, their upper ridges swept by winds carrying snow for months on end. Beneath, valleys and rivers lay crushed by ice, their shapes erased. For animals adapted to such conditions, muskoxen, mammoths, woolly rhinoceros, there was still life to be found along the fringes. But for humans hoping to cross from one side to the other, the prospect would have been suicidal. Ice sheets are not static, they flow, crack and carve. Crevasses split open without warning, meltwater pools collapse into torrents. Any attempt to traverse them would have meant crossing hundreds of kilometres of shifting, barren ice without food, firewood or shelter. This barrier is central to why archaeologists and geneticists debate the timing of migration into the Americas. If humans had attempted to enter during the peak of glaciation, they would have been confronted by an unbroken shield of ice. Only later, when climates warmed and the glaciers began to retreat, did corridors begin to open. Reconstruction suggests that a passage between the Laurentide and Cordilleran sheets may have become viable only around 14,000 to 13,000 years ago. Before that, even if narrow cracks had appeared, they would have been sterile wastelands with little vegetation or game, offering no means to sustain long journeys. The so-called ice-free corridor that later opened through what is now Alberta and British Columbia was not a highway waiting to be used. It was an ecological desert at first, barren until plants and animals recolonised the thawed ground. What this means is that the timing of the first settlement south of the ice sheets cannot be earlier than the landscape allowed. If archaeological evidence shows humans in the Americas before the corridor was open, it forces us to reconsider other routes. But even setting those debates aside, the image of the wall of ice is powerful on its own terms. It reminds us that geography sets the stage for human history. The ancestors of the first Americans were not held back by lack of courage or ingenuity, but by a continent itself transformed into a fortress. Scientists reconstruct these environments not only through glacial geology, but also by analysing pollen grains, ancient soils, and isotopes in ice cores. These tiny fragments confirm that during the last glacial maximum, North America's climate was brutal. Winters stretched on for most of the year. Summers were short and cool, often failing to melt the snowpack. Winds carved the landscape into frozen dunes. Even south of the ice sheets, much of the continent was dominated by dry steppe and sparse woodlands, suitable for herds of giant mammals but demanding for human survival. It is worth pausing to reflect on the human scale of this reality. Imagine being part of a small group of hunter-gatherers in Beringia gazing southward. You know from following game or scouting expeditions that the land ahead is blocked. The horizon itself is ice. You have no knowledge of what lies beyond, no way to predict when or if the wall will retreat. Generations might pass before a passage becomes possible. For those people, the ice was not just a physical barrier, but a psychological one, a reminder that the world was divided, and yet the ice did eventually retreat. By around 15,000 years ago, the glaciers had begun to pull back. Meltwater carved rivers across the plains. Vegetation started to recolonize exposed soil. Caribou and elk followed, creating pathways of life through what had been sterile ice. Humans, watching and waiting in the north, would have seen these signs. The continent was no longer entirely sealed. Possibilities that had been closed for millennia were opening again. The barrier was crumbling, but slowly in fits and starts. The haunting question that lingers is how many generations lived and died on the northern side of that wall, never knowing that beyond it lay a continent vast and fertile. How many stories were told of the impassable ice? How many myths grew around its immensity? We can only guess. What we do know is that the wall of ice shaped the destiny of the Americas. It dictated when humans could enter, how they would move, and where they could survive. In that sense, it was not just a backdrop to human history, but an actor in it. When we talk about the last glacial maximum, it is tempting to imagine a frozen planet where everything was locked in stillness. But the reality is that ice itself is alive in its own way. It advances and retreats, grinding mountains into dust, damming rivers, and sculpting entire valleys. The Laurentide and Cordilleran ice sheets were not uniform slabs of frozen water, but dynamic giants, creeping southward year by year, reshaping the continent with relentless force. Beneath their crushing weight, the Earth's crust literally sagged, only to rebound slowly once the ice retreated. This process, known as isostatic rebound, means that even today parts of Canada are still rising after having been depressed under ice for tens of thousands of years. For humans living in the far north, this constant transformation would have been both a threat and a source of knowledge. Seasonal meltwater spilling from the ice sheets carved enormous rivers and temporary lakes, redirecting landscapes overnight. Glacial lakes the size of small seas appeared and disappeared across what is now the Canadian Shield and the Northern Plains. To a hunter-gatherer group watching from a distance, these shifting waters would have been uncharted hazards, but also signposts of change. The growing floods signalled that the glaciers were no longer invincible, that the continent itself was in transition. The animals too responded to these shifts. Megafauna like mammoths, steppe bison, and giant ground sloths grazed on the periphery of the ice sheets where grasses and shrubs still clung to life. Their migrations traced the narrow zones of survivable habitat, corridors that humans could follow. Predators, dire wolves, saber-toothed cats, short-faced bears, patrolled the same margins. For a human community, the ice was not just a wall to the south. It was the reason that animals congregated in dense numbers along its edge. Life clustered where it could, and so too did people. Scientists piecing together this environment use evidence far more fragile than bones or tools. Tiny grains of pollen preserved in lake sediments tell us what plants grew along the ice margins. Layers of loess, wind-blown silt, record the strength and direction of ancient winds. Even the shells of microscopic organisms in ancient lakes preserve chemical fingerprints of past temperatures. Each of these clues adds a brushstroke to the reconstruction of a continent divided in two, an icy, uninhabitable north, and a drier, colder, but still viable south. This duality is what made the timing of migration so crucial. If humans attempted to move south too early, they would have been swallowed by ice. If they waited, the land itself changed beneath their feet as corridors opened and ecosystems revived. The margin for survival was thin. To us, 20,000 years may seem like a frozen moment in deep time, but for those living it, It was a span of countless lifetimes in which the wall of ice seemed eternal. Only when climates shifted and the glaciers yielded could opportunity return. Perhaps the most sobering aspect is that we know people were waiting on the northern side. Genetic evidence shows that lineages ancestral to Native Americans already existed in Beringia by this time. They were poised for expansion, yet geography kept them locked in place. In that sense, the glaciers were not just barriers of nature but arbiters of human destiny. They decided when entire populations could move, when new lands could be entered, and when the story of the Americas could begin in earnest. And as we consider this, we must ask, how many paths of human migration elsewhere were likewise dictated by the rhythms of ice and climate? How many histories were written or erased by frozen walls that rose and fell with the turning of the Earth's orbit? If the interior was frozen shut, could the first Americans have come by sea? It sounds improbable at first, almost too daring for people without metal ships or compasses, yet the evidence we have forces us to take this coastal gamble seriously. Between 18,000 and 15,000 years ago, the immense Laurentide and Cordilleran ice sheets still blocked the overland route into the Americas. If humans were present south of the ice before those glaciers had receded, as multiple sites suggest, they must have found another way. The most plausible alternative is the Pacific shoreline, a narrow ribbon of refugees where ice-free pockets and kelp forests could have sustained small bands of travellers inching southward by boat. This idea, often called the 𝐓𝐈𝐌𝐿 hypothesis, rests on the recognition that coastlines are not barren edges, but some of the most productive ecosystems on Earth. Along the Pacific Rim, from Japan to California, cold, nutrient-rich waters nourish forests of kelp. These giant seaweeds create entire marine worlds, supporting fish, shellfish, seals, seabirds, and even edible algae that humans could harvest directly. Archaeologists argue that if humans had already mastered boat travel in Asia and were familiar with exploiting marine resources, then the coasts of Beringia and the Pacific Northwest would have offered a lifeline. Instead of a desperate dash across glaciers, migration could have been a slow drift along beaches, estuaries, and sheltered bays. Skeptics have long pointed out that we lack direct archaeological proof of such a journey. No boats survive from this time. Wood and hide rot quickly, and the shorelines people would have used are now drowned under the Pacific, submerged as sea levels rose more than 100 metres after the glaciers melted. Yet absence of boats is not evidence of absence. We know that humans reached Australia at least 50,000 years ago, a voyage that required crossing open water. If seafaring was within our ancestors' reach so early, it would be astonishing if it had been abandoned by the time humans stood on the edge of Beringia, facing a coastline thick with resources. One of the strongest hints that people may have moved this way comes from far to the south, in Chile, at the site of Monte Verde. Here, in a peat bog preserved by waterlogged soils, archaeologists uncovered remains of a small settlement dating to about 14,500 years ago. The preservation is extraordinary. Ropes twisted from plant fibres, wooden tent frames, hearths still containing charcoal, fragments of medicinal plants, and even scraps of seaweed. 9 different species of seaweed were identified, some edible, some medicinal, and crucially, some sourced from beaches dozens of kilometres apart. Whoever lived at Monte Verde knew the coast intimately and relied on its resources. Their presence so far south, so early, strongly suggests that migration along the Pacific edge was not only possible but likely. Still, the coastal route remains difficult to test. The very landscapes we most want to excavate, ancient beaches, estuaries and tidal flats, are now deep underwater. What survives on higher ground is only the faintest trace of a larger story. Some researchers are optimistic that underwater archaeology may one day recover these hidden campsites, but for now the argument must be made by inference. We know people were in South America earlier than the interior corridors allowed. We know kelp forests would have provided abundant food. We know humans were capable of seafaring elsewhere. The coastal gamble is not proven beyond doubt, but it is increasingly difficult to ignore. For the people themselves, this was less a gamble than a practical adaptation. They did not need to think of themselves as explorers charting unknown waters. They were hunters, fishers, and foragers, moving steadily through environments they could manage. Each small boat carried knowledge: how to stitch hides, how to carve paddles, how to predict tides. Each campfire along the shore represented another step southward, another season survived. It may have taken centuries, but in time, the shoreline became a pathway into a continent that seemed closed from every other side. The haunting question that lingers is how much of this story is lost beneath the sea. Beneath the waves of the modern Pacific lie the drowned landscapes of the first Americans, coves where boats were pulled ashore, estuaries where shellfish were gathered, cliffs where fires once burned. We can only guess at the scale of this lost archaeology. What we do know is that without daring to hug the edge of ice and ocean, the story of the Americas would be much harder to explain. If we look at the broader human story, the possibility of a coastal migration into the Americas does not seem so radical. Humans had already shown again and again that water was less a barrier than a medium of movement. Reaching Sahul, the combined landmass of Australia and New Guinea, before 45,000 years ago required boats capable of crossing at least 60 kilometres of open ocean. The islands of Wallacea were peopled even earlier. These journeys did not happen by accident. They required planning, toolkits, and cultural knowledge of currents, tides, and winds. By the time humans were living in Northeast Asia and Beringia, it is reasonable to assume that some of this maritime tradition persisted, even if the vessels themselves are long gone. The Pacific Rim may have seemed daunting, but it was familiar ground to a species that had already mastered island hopping elsewhere. In fact, coastlines may have been especially attractive during the climatic swings of the late Pleistocene. Interior regions often fluctuated between aridity and glaciation, leaving resources patchy and unpredictable. By contrast, marine ecosystems were buffered from these extremes. Kelp forests did not vanish when temperatures dropped. Shellfish beds remained reliable, seals hauled out on beaches in predictable seasons, seabirds nested in colonies that could be harvested. For groups navigating uncertainty, following the shoreline would have provided continuity. Even if game was scarce inland, the sea offered fish and edible plants year-round. This line of reasoning helps explain why early South American sites like Monte Verde preserve so many coastal signatures. The presence of multiple species of seaweed gathered from different areas suggests not only familiarity with the shoreline, but also mobility along it. People were moving back and forth, harvesting different resources, and perhaps trading knowledge between groups. Such behaviour is entirely consistent with a coastal migration route that stretched thousands of kilometres. The leap from foraging along local bays to steadily advancing down the Pacific coast is not such a leap at all. It is the natural extension of habits already in place. We should also remember that travel along a coast does not mean hugging every cliff or battling open seas. Much of the Pacific Northwest and further south offered sheltered fjords, estuaries and island chains that could break journeys into manageable stages. A family group with hide-covered boats could travel a day or two, establish camp, exploit resources, and then move again when conditions allowed. Migration in this sense was not a single grand voyage, but a mosaic of shorter movements, stitched together across centuries. By the time their descendants arrived in Chile, they may not have thought of themselves as migrants at all. They were simply people moving through landscapes that sustained them. And yet, as compelling as this picture is, the frustrating silence of the archaeological record remains. What traces could survive of a campsite built on a shoreline 15,000 years ago, later drowned by rising seas? Fires, bones, discarded tools, all swept away or buried under sediments. Even if these sites still exist, finding them requires specialised underwater surveys, a slow and costly effort. Until that day, the coastal gamble rests on indirect evidence, genetics, ecology, and the faint echoes of preserved sites like Monte Verde. The absence of proof does not mean absence of people. It means we are looking in the wrong places, or that the record has been erased. The drowned shelf of the Pacific holds secrets that we may or may not ever recover. The haunting thought is that some of the most decisive chapters of human history took place in landscapes now hidden beneath waves, where the first Americans pulled boats ashore, lit fires against the wind and looked south to a continent waiting to be discovered. What do 23,000-year-old footprints in the New Mexico desert mean for everything we thought we knew? Few discoveries in recent archaeology have jolted the conversation about the first Americans as much as the prints uncovered at White Sands National Park. They are not chipped stones or ambiguous bones that can be argued over for decades. They are human footprints, pressed into soft mud on the margins of an Ice Age lake and preserved beneath layers of gypsum. The moment you see them, there is no debate about whether people were involved. The question is when, and that is where the controversy begins. The footprints first came to attention in the early 2000s, when shifting dunes revealed faint outlines of human steps mingled with those of mammoth, ground sloth, and other Ice Age giants. Over the following years, teams from the United States Geological Survey and collaborating institutions began systematic excavation and dating. What they found was astonishing. Seeds of an aquatic plant, Rupia serosa, pressed into the same layers as the footprints, returned radiocarbon ages between 21 and 23,000 years ago. If these dates were correct, humans were walking across New Mexico during the absolute height of the Last Glacial Maximum, long before the ice-free corridor opened and long before most models allowed. The announcement made headlines around the world, but archaeologists did not immediately embrace the results. The problem was the nature of the seeds themselves. Aquatic plants can absorb old carbon from dissolved limestone in the water, a phenomenon known as the reservoir effect. This makes them appear thousands of years older than they really are. Critics argued that the white sand seeds might not reflect the true age of the footprints, but a skewed signal. Extraordinary claims require extraordinary evidence, and many insisted that stronger dating methods were needed before rewriting the timeline of the first Americans. In science, however, skepticism is not dismissal, but an invitation to test. And in the case of white sands, tests have continued. In 2022, researchers applied optically stimulated luminescence, or OSL, a technique that measures when grains of quartz were last exposed to sunlight. This method bypasses the reservoir problem of aquatic plants. The sediments enclosing the footprints returned ages consistent with the original radiocarbon results, around 23,000 years ago. Further studies examined pollen trapped in the same layers, with results again lining up with a glacial maximum age. Each new line of evidence has strengthened the case that these prints truly are older than any other undisputed human traces in the Americas. The details of the footprints themselves add to the story. Many are the steps of teenagers and children, alongside a few adults, suggesting a group engaged in routine activity near the water's edge. Some prints overlay the tracks of giant sloths, and in at least one case the animal seems to have reared up on its hind legs, perhaps startled by the humans. This is not just a matter of chronology, but of direct interaction, a frozen moment of Ice Age life where species crossed paths. It is difficult not to feel the immediacy, the squelch of mud, the shadows of great animals nearby, the knowledge that those tracks were never meant to be preserved but by chance became a message across millennia. Yet the implications are unsettling. If people were in New Mexico 23,000 years ago, they must have entered the Americas earlier still, perhaps before the glaciers sealed off interior routes. This raises the possibility of migrations that left no genetic descendants, early forays into the continent that were later overwritten by subsequent waves. The White Sands footprints in this view might not represent the ancestors of modern indigenous peoples, but a vanished chapter of human history in the Americas. That possibility is both sobering and fascinating. To know with certainty that humans were there, but to admit that we cannot trace their line forward. As the debate continues, the White Sands site has become a touchstone in the broader conversation about the peopling of the Americas. Some researchers remain cautious, asking for more cross-checking, more refinement of dates, more replication at other sites. Others argue that the evidence is now strong enough to accept. What unites them is the recognition that these prints are real, and that they force us to grapple with scenarios once considered unlikely. The haunting question is whether White Sands represents the first wave of people into the continent or merely one of many. How many other tracks were once imprinted on the mud of Ice Age lakes, never to be fossilized, erased by wind, rain, and time? How many stories of early human presence have vanished, leaving only this rare and improbable survival? We may never know. What we can say is that 23,000 years ago, in what is now a desert, people walked across a lakeshore side by side with giants, and unknowingly inscribed one of the earliest chapters of American history. Can butchered mammoth bones prove people lived in Canada 24,000 years ago? For decades, The caves of the Yukon have sat at the heart of one of the most enduring controversies in American archaeology. Known as the Bluefish Caves, these shallow limestone shelters near the border of Alaska were first investigated in the 1970s and quickly became famous for yielding thousands of bones from Ice Age animals: mammoths, horses, bison, caribou, preserved by the cold. At first glance, this was an ordinary Pleistocene assemblage, a record of the megafauna that once roamed the steppe tundra of eastern Beringia. But mixed among those bones were signs, subtle and contested, that humans had been there much earlier than most archaeologists were ready to accept. The claim rests not on stone tools or fire pits, but on the bones themselves. Some of the mammoth remains bear marks that do not look like the random breaks of frost or carnivore teeth. They appear instead to have been cut, scraped and fractured in ways consistent with human butchery. Flakes of bone, sharp-edged and shaped by deliberate blows, suggest that people might have been manufacturing expedient tools from the carcasses of animals. Radiocarbon dates on these specimens place them as far back as 24,000 years ago, squarely in the middle of the Last Glacial Maximum. If the interpretation is correct, it would mean that humans were living in eastern Beringia at a time when the rest of North America was sealed by ice, waiting in the Yukon cold for the world to open. Skepticism has been fierce. For years, many researchers dismissed the bluefish evidence as ambiguous at best. Bones break in complicated ways, and distinguishing human activity from natural processes is notoriously difficult. Could freeze-thaw cycles mimic cut marks? Could carnivore gnawing leave scratches that look artificial? Early publications on the site were criticised for lacking detailed microscopic analysis, and the idea of people living so far north so early seemed implausible to many. The Clovis first model still dominated when bluefish first entered the debate, and anything that pushed dates back by 10,000 years or more faced steep resistance. In recent years, however, the tide has shifted. A team led by Lauriane Bourgeon applied modern microscopic methods to re-examine the supposed cut marks. Their conclusion, published in 2017, was that at least some of the bone modifications are indeed the product of stone tools wielded by humans. Striations consistent with slicing muscle from bone, percussion fractures associated with marrow extraction, and patterns of repeated strikes suggested deliberate butchery rather than random damage. The verdict was not universal. Some marks remain ambiguous, but the balance of evidence tipped toward human presence. This re-evaluation reignited interest in the site and lent weight to the argument that people had already reached the Yukon during the coldest millennia of the Ice Age. If that is true, it changes the story in important ways. It suggests that human survival in the north was not only possible but established, and that populations may have persisted in Beringia throughout the glacial maximum, adapting to steppe tundra resources while waiting for new lands to open further south. The Bluefish Caves then become not a peripheral oddity, but a critical waypoint in understanding how the first Americans endured. Yet the haunting question remains: if people were in the Yukon 24,000 years ago, why is the archaeological trail so faint? Where are their camps, their hearths, their tools beyond broken bone? Did they live in ways that left only the most ephemeral traces, or have the key sites been lost under sediments and floods, or drowned by rising seas? The caves whisper a possibility, but the continent offers silence. Until more evidence is found, bluefish will remain both tantalizing and incomplete, a reminder of how fragile our window into deep time can be. What makes the Bluefish Caves so intriguing is not simply their age, but the context they sit within. These caves are perched in a part of the Yukon that was never covered by ice, a wedge of steppe tundra known as eastern Beringia. While much of North America was locked under kilometres of glacial sheets, this region remained open, swept by winds and dotted with hardy vegetation. It was cold, unforgiving, and yet ecologically alive. Horses grazed the plains, mammoths trampled the river valleys, caribou migrated through in immense herds. In this sense, the Yukon offered a refuge in an otherwise sealed-off continent, a place where people could wait out the long imprisonment of the ice. If the bone evidence of bluefish is authentic, it suggests that humans found this refuge and made it their own. To live in such a landscape, people would have needed a flexible strategy. The bones hint at an opportunistic lifestyle, one that relied not on elaborate tools or settled camps, but on quick responses to the animals at hand. a mammoth carcass could provide weeks of food, sheltering hides, fuel from the bones, and raw material for tools. But such opportunities were rare, so groups may have moved constantly, following herds and scavenging when predators left remains behind. Firewood would have been scarce, and winters unimaginably severe, but knowledge of local resources could make the difference between life and death. Archaeologists suspect that groups living here must have been small and mobile. Their traces faint because their camps were temporary and often revisited by carnivores or buried by sediment soon after abandonment. It is worth noting that the Bluefish Caves are not alone in hinting at early human presence in Beringia. Sites across Siberia show people were living at high latitudes long before 20,000 years ago. The Unna River site, for example, has yielded tools and ornaments from around 30,000 years ago, proving that humans could thrive above the Arctic Circle. If people were in Siberia at those latitudes, it is not a leap to imagine they could cross into the Yukon. What makes Bluefish unique is that it appears to capture their presence on the American side of the divide, holding fragile testimony that they made the leap and persisted. Another angle often overlooked is that caves like these are not just places of shelter, but also natural traps for evidence. Open campsites on the tundra may have been obliterated by erosion, or never left much material to begin with, but caves collect and protect. Bones fall in, accumulate, and are sealed away from the surface world. This means that the apparent uniqueness of Bluefish may reflect the bias of preservation, as much as the rarity of occupation. If other caves in the Yukon and Alaska were explored with the same intensity, more traces might emerge to reinforce or challenge the story. The question is whether we have been looking in the right places. The resistance that Bluefish evidence met for so long tells us something important about science itself. Archaeology, like any discipline, builds models that help explain patterns. For decades, the Clovis first model dominated, and anything that fell outside of its neat chronology was sidelined. But as new methods develop, microscopic analysis of cut marks, improved radiocarbon calibration, genetic data, old collections can be re-examined. The Bluefish bones are a case study in how knowledge evolves. What once looked ambiguous under the lens of the 1970s gains clarity under the microscopes of the 21st century. Our understanding is not static. It is sharpened by revisiting evidence with fresh eyes. The possibility of humans in the Yukon 24,000 years ago also reshapes how we think about cultural persistence. If small groups weathered the glacial maximum in Beringia, isolated for millennia, their lineages may have carried forward into the later expansion that swept across the Americas. Alternatively, they may have represented one of several failed colonizations, populations that endured for centuries but eventually vanished without descendants. Both scenarios remind us of how precarious survival was and how easily entire chapters of human history can vanish, leaving only contested marks on ancient bones. And so, the Bluefish Caves occupy a strange place in the narrative, not universally accepted, not entirely rejected, but suspended between doubt and possibility. They illustrate the fragility of deep history. We do not find the clear lines of spear points or the secure signatures of hearths. We find instead faint etchings on the bones of long-dead animals, clues that demand interpretation. Were they the handiwork of people butchering mammoths, or the incidental damage of wolves and frost? The debate itself is part of the story, a reminder that science thrives not on certainty but on questioning. The haunting image is of small groups huddled against the Yukon cold, living in a land that modern eyes see as marginal, yet one that may have been their entire world. To them, it was not a waiting room before the real migration into the Americas, but the centre of life, where generations were born, lived, and died. Whether their story ended in silence or flowed forward into later peoples, the Bluefish Caves preserve a whisper of their presence. That whisper forces us to confront the possibility that America's human history is older, deeper, and more complicated than we once dared to imagine. What can knife marks on a mastodon tusk tell us about humans in Florida before Clovis? To answer this, we have to dive, quite literally, into the murky sinkholes of the 𝐓𝐈𝐌𝐿𝐴 River, where one of the most remarkable and controversial underwater excavations in North America took place. The site is called Page-Ladson, named for the property owner and the diver who first brought attention to the deposits. At first glance, the spot looks like nothing more than a sluggish tea-coloured river winding through the forests of northern Florida. Beneath its surface, however, lies a time capsule sealed in sediment, holding traces of life from more than 14,000 years ago. Unlike many dryland archaeological sites where wind and erosion disturb layers, underwater deposits at Page-Ladson were blanketed with clay and silt that preserved organic material in exquisite detail. Excavations here have uncovered mastodon bones, plant remains, stone flakes, and perhaps most compelling of all, a mastodon tusk bearing a series of circular cut marks. To the trained eye, these cuts are unmistakably the work of stone tools, not of carnivore teeth or natural wear. They show where humans carved into the tusk to extract tissue, possibly to reach the nutrient-rich pulp inside. This single piece of evidence, fragile yet clear, is enough to push back the timeline of human presence in the southeastern United States. Radiocarbon dating of the tusk and surrounding material places the activity at around 14,500 years ago, centuries before the rise of Clovis culture. If correct, this means that Florida was not a late frontier of migration, but already inhabited by people comfortable enough to butcher massive Ice Age animals. The implications ripple outward. To reach Florida by this time, groups would have had to traverse much of the continent or move rapidly along coastal and riverine routes. Their presence in the southeast suggests that early dispersals were not slow trickles, but dynamic, wide-ranging movements. The Page-Ladson site is not without controversy. For years, discoveries there were largely ignored by the mainstream because they did not fit the prevailing models. When first reported in the 1980s and 90s, the idea of humans in Florida before Clovis was considered unlikely at best, fraudulent at worst. Critics argued that the cut marks might be misinterpreted, that the context was disturbed, that radiocarbon results were unreliable. What has changed since then is both technology and perspective. Improved accelerator mass spectrometry has confirmed the dates with greater precision, and careful underwater stratigraphy has shown that the layers remained intact. Independent teams revisited the tusk and concluded that the marks were indeed consistent with stone tools. Slowly, what was once dismissed as fringe is now cited as one of the clearest pieces of pre-Clovis evidence in the eastern United States. Beyond its scientific debates, Page-Ladson is a reminder of how much of prehistory lies hidden beneath water. During the last glacial maximum, sea levels were far lower than today, and much of the Florida coastline stretched miles further out. Rivers carved deeper channels, sinkholes filled with organic debris, and camps set up along their margins would have been drowned as the seas rose. If groups lived and travelled widely across this landscape, many of their traces are now inaccessible to traditional archaeology. Sites like Page-Ladson offer rare windows into that submerged world. What fascinates researchers about the tusk is not only its age, but what it implies about human-animal interactions. Mastodons were immense creatures, weighing several tons, equipped with formidable tusks and thick hides. To approach, kill, or even scavenge one required knowledge, courage, and coordinated effort. The cut marks show intent. They were not the random scratches of chance encounters, but purposeful acts of survival. Did the hunters bring down the mastodon themselves, or did they find a carcass and salvage what they could? Either way, the evidence ties human hands directly to Ice Age giants in the American Southeast. In the end, the haunting question is how many such stories remain unrecorded. How many sinkholes across Florida still hold bones marked by human tools? How many drowned river valleys conceal the camps and hearths of people who walked this land long before conventional history says they should have? Page-Ladson does not give us every answer, but it gives us a glimpse. A tusk etched with proof that people were here, shaping their world with stone tools and carving out a place in a landscape of giants. It reminds us that the past is not fixed, that even in familiar places, discoveries still lurk beneath the surface, waiting for someone patient enough to look. One of the most striking aspects of Page-Ladson is how its preservation reshapes what we think is even possible in American archaeology. In most parts of the continent, organic remains from more than 10,000 years ago have long since decayed, leaving us only stone and bone. But in the oxygen-starved depths of the Orcilla River, the mud worked like a vault, sealing in plant fibres, seeds, and even mastodon dung. For archaeologists, this kind of environment is a dream and a challenge. On the one hand, it preserves what is usually lost, allowing us to reconstruct diets and ecosystems in remarkable detail. On the other hand, it demands an entirely different style of excavation. Divers work in near darkness, hauling buckets of sediment through suction dredges, feeling rather than seeing much of what they recover. Every step requires both archaeological skill and the discipline of underwater training, making each artifact pulled from the silt the product of extraordinary effort. This unusual preservation is why Page-Ladson matters so much to the debate over early humans in the Americas. At many contested sites, critics argue that supposed artifacts might simply be rocks fractured by nature. At Page-Ladson, the conversation shifts, because we are dealing with organic material in direct association with human-modified bone. The tusk with cut marks was not found in isolation. It was buried alongside other remains in undisturbed layers, with radiocarbon dates cross-checked against multiple materials. That kind of context strengthens confidence in the evidence and makes it harder to dismiss with a wave of the hand. The broader setting of Florida during the late Ice Age also helps frame the site. Far from being the swampy subtropical landscape we know today, Florida then was a cooler and drier peninsula, extending far into what is now the Gulf of Mexico. Rivers ran across wide plains and sinkholes dotted the karst terrain. Mastodons, camels, and giant ground sloths roamed these areas, congregating near water sources. For human groups, such places would have been magnets. They provided both prey and predictable travel corridors. That Page-Ladson preserves evidence of people here makes ecological sense. It was the kind of place where you would expect them to appear, if they were in the region at all. The skepticism surrounding the site for decades also offers a lesson in how scientific consensus can shift. When the tusk was first described, the archaeological establishment was still deeply invested in the idea that Clovis culture represented the first Americans. Any claims of earlier presence were treated with suspicion, sometimes bordering on hostility. Page-Ladson was not alone in being sidelined. Other sites with early dates faced similar resistance. But as multiple lines of evidence, genetics, coastal hypotheses, footprints like those at White Sands, have converged on the idea of pre-Clovis presence, Page-Ladson has been reappraised. It now fits more comfortably into a broader pattern rather than standing alone as an outlier. Still, the site leaves us with puzzles. If humans were in Florida 14,500 years ago, where else were they? Why do we not see more sites of similar age across the southeast? The likely answer is preservation. Many traces of early life in Florida would now lie submerged on the continental shelf, inaccessible without large-scale underwater archaeology. What Page-Ladson offers is a rare glimpse through a keyhole, showing us just enough to prove presence, but not enough to sketch the full picture. The haunting thought is that without that one tusk, carefully recovered and patiently studied, we might still think of Florida as empty during the Ice Age. Instead, we now imagine people standing by the Orcilla River, cutting into a mastodon with stone tools while giant reptiles slid beneath the surface of nearby waters. Their world was rich, dangerous, and fleeting, and for a brief moment it has come back into view through the quiet work of archaeology beneath the river's dark flow. Why did populations suddenly spread so fast after 16,000 years ago? For tens of millennia the Americas had been sealed behind walls of ice, and then, seemingly in the blink of an archaeological eye, humans appeared across the continent. This sudden expansion is one of the most dramatic population movements in human history, and its speed still startles researchers. We see the traces in both genetics and archaeology, a great branching of lineages, a rapid dispersal across diverse environments, and the unmistakable signs of people adapting to landscapes they had never encountered before. The genetic record gives us one of the clearest windows into this event. Analyses of ancient and modern DNA show that by around 16 to 15,000 years ago, the ancestral population that had endured its long standstill in Beringia began to split into distinct groups. One lineage gave rise to what we call the Northern Branch, ancestral to peoples who remained across much of North America. Another became the Southern Branch, which would spread across the southern United States, into Mesoamerica, and eventually deep into South America. These were not subtle divergences that took thousands of years. The branching is abrupt. Like a tree struck by lightning, signalling a population that suddenly found vast new territory open to it and expanded rapidly into that space. Archaeology confirms what the DNA hints at. Within only a few centuries after the ice began to retreat, sites appear far apart from each other, suggesting long-distance movements across enormous landscapes. In genetic terms, this kind of rapid expansion often creates what scientists call a founder effect, where small groups push into new areas, carrying only a fraction of the genetic diversity of the parent population. Over time, these groups diverge from each other, not because they were intentionally separate, but because distance and isolation reshape their inheritance. That pattern is exactly what we see in the Native American lineages that emerge south of the ice sheets. Why the suddenness? Part of the answer lies in climate. As the world warmed after the glacial maximum, corridors of vegetation opened, lakes filled with fish, and herds of game animals moved into new pastures. For a population that had been bottlenecked in Beringia for thousands of years, the release of ecological pressure must have felt like a floodgate opening. Groups that had honed their survival skills in the demanding north now found landscapes rich with opportunities. Rivers teemed with salmon, grasslands with bison, forests with deer and smaller prey. The energy locked in these environments fueled human growth and mobility. But climate alone cannot explain the pace. Human ingenuity also played a role. By this time, these populations were not tentative wanderers. They were skilled toolmakers, cooperative hunters, and explorers by necessity. The expansion into the Americas was not the first time humans had surged into new continents. Eurasia and Australia had already been colonized tens of thousands of years earlier. The people who moved south of the ice carried with them both cultural memory and adaptive flexibility. They knew how to read landscapes, how to exploit different niches, and how to push boundaries. Once the constraints were lifted, they did what our species has always done. They spread. This rapid dispersal raises haunting questions. What did it feel like to be part of those first waves, moving into valleys and plains that had never known human presence? Did they see themselves as pioneers? Or was it simply the ordinary act of following herds and searching for water? Archaeology cannot give us their thoughts, but it does suggest that they carried traditions with them, even as they fragmented into new branches. The genetic split into northern and southern groups was not the end of a story, but the beginning of dozens more, each tied to a particular river, coast, or mountain range. What we're left with is the image of a continent suddenly filled with footsteps, not through a slow trickle, but a cascade. In only a few thousand years, humans reached from Alaska to Patagonia, from the deserts of the southwest to the forests of Amazonia. The expansion was not uniform, not without setbacks, and not always permanent, but its pace is without parallel. To say that humans spread rapidly south of the ice is an understatement. They remade the map of the Americas in a single burst of movement, and in doing so, laid down the foundations for the immense diversity of indigenous cultures that would follow. The haunting question remains, why then, and not earlier? Were there attempts before the ice retreated that failed, leaving no trace in the present? Or was it simply that timing and environment aligned perfectly after 16,000 years ago, creating the first real opportunity for sustained dispersal? The evidence suggests the latter, but the silence of earlier millennia keeps the door open to possibilities. In this uncertainty, we're reminded that our knowledge is provisional, stitched together from fragments of bone, strands of DNA, and a handful of sites that survived by chance. ChatGPT said, "The sudden spread south of the ice is not just a story of people moving into empty landscapes. It is also a story of choices, of how small bands navigated the uncertainty of entirely new worlds. When geneticists talk about a branching population, they are often describing the outcome of hundreds of micro-decisions made by families, whether to linger by a river where salmon spawned, or to follow mammoths further inland, or to strike out along a coastline dotted with kelp beds and seabirds. Each decision meant leaving others behind, and over time those choices crystallized into separate lineages. We often speak of splits in abstract terms, but in lived reality they were separations of siblings, cousins and friends who never met again once distance grew too great. The archaeological traces of this dispersal are faint but telling. Even without invoking specific sites, we know from the distribution of radiocarbon dates and environmental reconstructions that the pace was remarkable. In evolutionary terms, a few thousand years is a heartbeat. Yet within that span, humans had already adapted to deserts, forests, high mountains and tropical lowlands. This capacity for rapid adjustment is something we often take for granted, but it is worth pausing on. To shift from the windswept tundra of Beringia to the hardwood forests of the eastern woodlands or the arid plateaus of the interior west required not just endurance, but cultural flexibility. Hunting strategies, seasonal movements, and toolkits had to evolve quickly, often within the span of a single generation. One reason this expansion could succeed is demographic momentum. Populations emerging from a bottleneck often grow rapidly once constraints are lifted. After thousands of years of limited resources in Beringia, the southward dispersal unleashed human fertility in landscapes rich with protein and carbohydrates. Archaeologists suspect that population densities rose swiftly, not in the millions of people we imagine today, but enough to sustain long-distance networks and maintain viable gene flow across regions. In this light, the rapid filling of the continent is not mysterious at all. It was the predictable consequence of people long held in check suddenly gaining access to abundance. Yet abundance can also lead to conflict. While our evidence is fragmentary, the sheer speed of expansion suggests that groups would sometimes have collided at ecological frontiers, competing for river valleys or hunting territories. Did they negotiate, intermarry, or fight? We cannot say with certainty, but the genetic diversity within both the northern and southern branches hints that alliances and exchanges must have played a role. No single group monopolized the expansion. Instead, it was a tapestry of movements, some successful, some ephemeral. Looking at the broader picture, the dispersal south of the ice foreshadows a pattern that repeats in human history. The tendency of our species to turn ecological thresholds into opportunities for swift transformation. Just as later farmers would spread across Europe in a surge, or herders would expand across the steppes, these early Americans seized the chance to occupy vast new terrain. What distinguishes their story is the speed with which they moved from a standstill to a continental sweep. That transition remains one of the great turning points in the human journey, and even if we cannot reconstruct every path, the echoes of that expansion still shape the genetic and cultural landscapes of the Americas today. How did people reach Chile before the so-called first Americans supposedly existed? For most of the 20th century, the consensus held that humans entered the Americas only around 13,000 years ago, their presence marked by the distinct fluted stone tools of the Clovis culture. Yet in the far south of Chile, on a damp creek bank called Monte Verde, archaeologists uncovered something that shattered this timeline. Beneath layers of peat, they found evidence of human life dated to nearly 14,800 years ago, at least 1,000 years before Clovis even appears. This discovery forced a reckoning. If people were living in southern Chile so early, then the story of the Americas is not one of a single pioneering migration, but of a deeper, more complex process. The Monte Verde site is extraordinary not only because of its age, but because of its preservation. Peat bogs are nature's archivists, sealing away organic material in waterlogged layers where oxygen cannot easily reach. At Monte Verde, this created an environment where wood, plant fibres and even food residues endured for millennia. Archaeologists led by Tom Dillehay uncovered the remains of a long tent-like structure, built of wooden posts lashed together and covered with animal hides. It stretched nearly 50 feet and appeared to be divided into compartments, each with its own small hearth. The impression is not of a temporary hunting camp, but of a semi-permanent dwelling, a place where families cooked, ate, and perhaps slept under the same roof. What makes Monte Verde so compelling is the wealth of everyday details. Alongside the hearths were traces of wild potatoes, edible seeds, berries, and nuts. Medicinal plants were present as well, suggesting knowledge of healing practices. Mastodon bones bore signs of butchery, indicating that people were hunting or at least processing large animals. Even lengths of twisted cordage survived, evidence of fibres being spun into ropes or nets. These details allow us to glimpse daily life with unusual intimacy. We do not see only the hunters of Ice Age megafauna, but gatherers of plants, crafters of fibres, and caretakers of households. It is a portrait of a community, not just an expedition. One of the most provocative aspects of Monte Verde is what is absent. Nowhere among the artefacts do we find Clovis points or anything resembling them. Instead, the stone tools are simple flakes and scrapers, functional but unspectacular. For decades, defenders of the Clovis first model argued that Clovis technology represented the signature of the earliest migration, and that earlier evidence was suspect unless it showed a direct technological link. Monte Verde disproved this. Here were people living long before Clovis, thriving with a toolkit entirely their own. Their presence meant that the first Americans could not have been defined by a single technology. The dating of Monte Verde sparked fierce debate. Early critics suggested that contamination or misinterpretation had skewed the radiocarbon results. But layer after layer of testing confirmed the age, and in the late 1990s a panel of skeptical archaeologists visited the site. After examining the evidence firsthand, even long-standing opponents agreed that the site was genuine. Monte Verde became the turning point, the site that cracked open the wall of dogma and made room for pre-Clovis archaeology. How did people reach southern Chile so early? That question remains unsettled. If we accept the dates, then migration into the Americas must have begun thousands of years earlier than once believed, allowing enough time for people to travel from the north to the far south. Some argue this is best explained by a coastal migration, where groups followed marine resources down the Pacific Rim, moving with relative speed along beaches and estuaries. Others suggest inland routes may have opened earlier than we think, though this is harder to reconcile with glacial barriers. The truth may never be fully known, but Monte Verde proves that by 14,800 years ago, people were already living at the end of the world. The haunting question raised by Monte Verde is not simply how they got there, but who they were. Were they ancestors of the later populations who spread across South America, or were they part of a wave that eventually faded, leaving no direct descendants? The site gives us no human remains to answer that definitively. What it gives us instead are the imprints of dwellings, the fragments of meals, the remains of tools. It shows us that humans were here, resilient and inventive, adapting to a new continent with the same resourcefulness that had carried them across the old world. In the quiet peat bogs of Chile, preserved under layers of damp soil, lies the evidence that history begins earlier than we thought. Monte Verde reminds us that the Americas were not an untouched wilderness waiting for Clovis hunters to arrive, but a land already inhabited by people who carried knowledge, traditions, and families with them. They were not footnotes to the Clovis story. They were the beginning of their own. Can 15,000-year-old tools buried beneath Clovis layers rewrite prehistory? In the rolling countryside north of Austin, Texas, archaeologists excavated a site that has become one of the most important testing grounds for this question. Known as the Buttermilk Creek Complex, it sits in a quiet setting along a tributary, but beneath its unassuming surface lies a sequence of sediment that may upend the neat timeline once drawn for the first Americans. What makes Buttermilk Creek exceptional is not just a handful of artifacts, but sheer quantity. More than 15,000 pieces of stone debitage and tools were recovered from layers beneath those that contained classic Clovis points. These lower levels yielded blades, scrapers and bifaces, stone artifacts that had been deliberately crafted by human hands. The challenge, of course, was proving their age. Unlike organic remains, stone cannot be radiocarbon dated, and the site lacked the bones or charcoal that usually anchor such estimates. Instead, archaeologists turned to a technique known as optically stimulated luminescence, or OSL, which measures the time since grains of sediment were last exposed to sunlight. By carefully sampling the soil layers, scientists determined that the pre-Clovis artifacts dated back to about 15,500 years ago, give or take several centuries. This was older than the accepted window for Clovis, which clustered between about 13,100 and 12,800 years ago. In other words, long before the supposedly first Americans arrived, people were already napping stone along this creek in Texas. The implication was clear. Clovis was not the starting point of human history in the Americas, but a later development within a broader and older story. The sheer volume of artifacts adds weight to this interpretation. A single questionable point might be explained away as an out-of-place intrusion, but thousands of pieces forming a consistent assemblage are harder to dismiss. Archaeologists at Buttermilk Creek argue that the tool types represent a precursor technology, an evolutionary step on the way to Clovis. If correct, this site preserves the missing link between earlier arrivals and the later widespread Clovis tradition. Some researchers describe it as experimental stonework, a population adapting techniques that would eventually coalesce into the iconic fluted point style. Yet, as with all claims that rewrite textbooks, skepticism has followed. Critics point out that OSL dating, while powerful, carries larger error margins than radiocarbon, making precise chronological arguments more difficult. They ask whether the artifacts might have been displaced downward through natural processes, or whether the sediment layers were as secure as claimed. The site's defenders counter with meticulous stratigraphy and careful controls, showing that the artifacts were indeed in situ. The debate continues, but the site's scale and consistency make it hard to dismiss outright. Buttermilk Creek also forces us to rethink the geography of early settlement. Texas lies far south of the glacial barriers, in a relatively temperate zone that would have been attractive to early groups moving through the continent. If people were here by 15,000 years ago, then dispersal must have occurred swiftly after the ice retreat, perhaps through coastal or inland corridors earlier than once thought viable. It raises the possibility that Clovis did not originate from a northern entry point, but may have crystallized in regions like Texas, where earlier traditions were already flourishing. Perhaps the most thought-provoking aspect of Buttermilk Creek is how ordinary it looks. Unlike Monte Verde's preserved huts, or Page-Ladson's dramatic underwater Tusk, this site is simply layers of dirt holding flakes of stone. There is no spectacle, only the quiet persistence of thousands of artifacts stacked beneath our feet. And yet from this unglamorous record emerges a profound challenge to orthodoxy. The very banality of the evidence is what makes it powerful. Ordinary people crafting ordinary tools long before the supposed dawn of American prehistory. The haunting question it leaves us with is not just whether Clovis was first, but why we were so eager to believe it had to be. Was it the elegance of the points, the neatness of the timeline, the comfort of a single origin? Buttermilk Creek reminds us that human history is rarely neat. It is messy, layered, and sometimes buried in places we least expect, waiting for light to strike the grains of sediment and reveal just how long it has been since a toolmaker's hand last touched stone. One way to appreciate what Buttermilk Creek contributes is to compare it with the larger pattern of archaeological discovery in the Americas. For most of the 20th century, researchers tended to focus on dramatic, singular finds. An elegant spear point lodged in the bones of a mammoth, or a burial richly stocked with grave goods. These were visible, photogenic, and easy to tell stories about. Buttermilk Creek offers something different. Instead of a single iconic object, it provides the cumulative weight of thousands of small pieces, the everyday debris of toolmaking. Archaeologists sometimes refer to these as lithic scatters, the unglamorous byproducts of chipping away stone. Individually they might seem trivial, but together they form a pattern that is unmistakably human. This shift in emphasis, from spectacular finds to patterns of ordinary activity, reflects a broader change in how archaeologists think about the first Americans. Rather than seeking a single dramatic moment of entry or invention, researchers now look for evidence of gradual adaptation, multiple overlapping traditions, and subtle technological experimentation. Buttermilk Creek sits at the heart of that approach. It shows us people living in continuity, leaving behind a steady record of work and discard, not an isolated breakthrough. The site also underscores the importance of context. Many contested early sites have been criticised because the artefacts appeared without clear stratigraphy or were found in disturbed layers where dating was unreliable. At Buttermilk Creek, the painstaking documentation of sediment layers, artefact positions and dating techniques provides a stronger case. It demonstrates that careful excavation and rigorous methodology can push the boundaries of what we know without collapsing into speculation. For a field that has been burned before by overreaching claims, this balance of ambition and caution is crucial. Another dimension worth considering is how Buttermilk Creek fits into the landscape of central Texas itself. This region sits at the crossroads of ecological zones, grasslands to the north and west, woodlands to the east, and river valleys cutting through in all directions. For hunter-gatherer groups, Such diversity offered flexibility. They could hunt bison on the plains, gather nuts in the forests and fish in streams, all within a relatively short range. Sites like Buttermilk Creek suggest that early groups were not merely passing through, but may have been taking advantage of this ecological bounty for extended periods. The presence of so many artifacts hints at repeated visits or long-term occupation. While we may not be able to reconstruct the social structure of these groups, the density of material implies more than just a few transient families. It suggests communities returning over generations, perhaps because the place offered reliable water and stone resources for tool-making. In this sense, Buttermilk Creek is not just a site of early Americans, but a reminder of how humans anchor themselves in landscapes, forming connections that persist through time. Finally, the debates surrounding the site reflect an enduring tension in archaeology, the balance between skepticism and openness. On one hand, extraordinary claims require extraordinary evidence, and the burden of proof lies heavy on those who challenge orthodoxy. On the other, clinging too tightly to established models risks missing the very discoveries that expand our understanding. Buttermilk Creek sits precisely at this intersection, embodying both the controversy and the promise of rethinking first settlement. As we step back, the lesson is that history is rarely rewritten by a single artifact. More often, it is reshaped by the slow accumulation of data, thousands of flakes, carefully dated layers, and patterns that only emerge when the evidence is viewed as a whole. Buttermilk Creek may not give us a grand narrative in itself, but it forces us to widen the frame, to accept that people were present in the Americas earlier than Clovis, and that their lives were filled with the same quiet routines of work, adaptation, and persistence that define all of human history. What does 19,000 years of continuous habitation look like? To answer that, we travel to the wooded hills of western Pennsylvania, to a sandstone overhang that has quietly recorded layer after layer of human life. Known as Meadow Croft Rock Shelter, this site has been both a treasure trove and a lightning rod in the debates over the peopling of the Americas. It is not flashy in appearance, a shallow recess in a cliff face overlooking a small tributary of the Ohio River. But within its deposits lies one of the longest and most detailed records of human presence on the continent. Excavations began in the 1970s under the direction of archaeologist James 𝐓𝐈𝐌𝐿𝐿, who soon realised that Meadowcroft was no ordinary site. As his team dug through the sediments, they uncovered evidence of occupation spanning millennia, from historic Native American use all the way back to layers that radiocarbon dated nearly 19,000 years ago. In those deepest levels were hearths with charcoal, stone tools of distinctive styles, and food remains including nuts, seeds, and small animal bones. If these dates were accurate, Meadowcroft was older than Clovis by thousands of years, providing compelling proof of pre-Clovis habitation on the eastern seaboard. The evidence was detailed and varied. Charred hickory nuts and wild grapes showed that the inhabitants harvested local plants, while bones of wild turkey, rabbit, and deer indicated hunting of small to medium game. Unlike the stereotypical image of Ice Age hunters exclusively chasing mammoths, Meadowcroft's residents clearly embraced a broad-spectrum diet. They exploited what was available in the forests and streams around them, a strategy that likely made survival more secure. The stone tools found in these levels included blades, scrapers, and bifaces made of locally available chert. None of them resembled Clovis points. Instead, they reflected a technological tradition of their own, adapted to the needs of people living in a temperate woodland rather than open steppe. What makes Meadowcroft stand out is not just its antiquity, but its continuity. Unlike many early sites that represent brief occupations, Meadowcroft shows evidence of repeated use over thousands of years. Layer upon layer of hearths, tools, and food remains reveal that people kept returning to this rock shelter across changing climates and shifting ecosystems. Through the Last Glacial Maximum, the warming that followed, and the eventual spread of agriculture much later, this place remained a magnet. Archaeologists speculate that its appeal lay in its position, sheltered from the elements, overlooking water, and surrounded by diverse resources. It was a natural hub for human life, yet, as with other pre-Clovis sites, Meadowcroft has not escaped controversy. Some critics in the early years argued that the radiocarbon dates might have been skewed by ancient coal contamination in the sediments. Others questioned whether the artifacts truly represented human craftsmanship or natural fractures. Over decades, however, further analysis and refinement of dating methods have strengthened the case. Independent studies have confirmed the antiquity of the deepest layers, and the integrity of the site is now more widely accepted than it once was. Meadowcroft today stands as one of the most credible pre-Clovis sites in North America. What does 19,000 years of occupation mean in human terms? It means that generation after generation of families returned to the same sandstone ledge, built fires in much the same place, and left behind their scraps of meals. It means that over centuries tools accumulated, traditions persisted, and perhaps even stories were told about the shelter itself. A place like Meadowcroft blurs the line between camp and home. It was never a city or permanent village, but it was also not a one-night stop. It was something in between, a persistent landmark in the landscape of early Americans. The haunting question Meadowcroft leaves us with is this: how many other such shelters, occupied and reoccupied through the deep past, have vanished without trace? Meadowcroft survived because its deposits were sealed and protected, but countless other sites along rivers and ridges have been eroded away or buried beyond recovery. For every known record, there are likely dozens more we will never find. Meadowcroft thus reminds us of both the richness of early American life and the fragility of its archaeological record. When thinking about Meadowcroft, it helps to imagine the broader landscape in which the shelter stood. Western Pennsylvania during the late Pleistocene was not the familiar patchwork of cornfields, towns, and highways we see today. It was a shifting mosaic of boreal forests, open parklands, and glacial outwash plains. Seasonal changes would have been pronounced, with winters harsher and summers shorter than modern conditions. For early inhabitants, the rock shelter offered not just refuge from rain or snow, but also a stable anchor point in a volatile environment. Having a dependable site to return to year after year may have reduced the risks of life at the margins of the Ice Age world. Another striking feature of Meadowcroft is how it reflects the adaptability of its occupants. The long record of use shows that as climates shifted, so too did the people's strategies. When colder, more open habitats dominated, they hunted animals suited to those conditions. As forests expanded, their diets diversified to include more plant foods and smaller woodland creatures. This capacity to adjust, sometimes called broad-spectrum foraging, is what allowed human populations to thrive in landscapes that were constantly changing. Meadowcroft is a case study in resilience. Rather than being locked into a single hunting strategy, its occupants continually recalibrated their relationship to the land. This resilience raises questions about mobility. Were the groups who returned to Meadowcroft the same people across centuries, passing down knowledge of the site through oral tradition? Or was the shelter rediscovered repeatedly by unrelated bands moving through the region? Archaeology cannot provide a definitive answer, but the pattern of continuity makes it tempting to imagine some form of cultural memory. Perhaps parents told their children of the reliable shelter by the creek, or perhaps a trail system led wanderers back to its familiar ledge. Whatever the mechanism, the site's long-term use hints at an early geography of human landmarks, places imbued with meaning that persisted across generations. The richness of Meadowcroft's archaeological record also challenges assumptions about how early Americans lived. The prevailing image of highly mobile hunters racing across the continent to follow herds of megafauna has been tempered by evidence from sites like this one. Instead of constant wandering, there may have been cycles of movement anchored by favoured base camps. Meadowcroft might have served as such a base, a place where families gathered, resources were stored, and tasks like tool-making or food processing were carried out. The presence of diverse plant remains, including edible seeds and fruits, suggests that people stayed long enough to harvest seasonal foods rather than passing through in haste. We should not forget that Meadowcroft's importance extends beyond the technical debates of archaeology. For native peoples today, the site is a reminder of the deep antiquity of their ancestors in eastern North America. It confirms that humans had been shaping and inhabiting these landscapes long before the arrival of Europeans, long before even the famous Clovis hunters. The persistence of Meadowcroft's use underlines a truth often overlooked in the textbooks. The first Americans were not fleeting shadows on the land, but enduring communities with deep time roots. And yet, even with all it tells us, Meadowcroft remains enigmatic. The artifacts and eco-facts give us tantalizing fragments of daily life, but the voices of its occupants are lost. We cannot know the names they gave to the river, the stories they told by firelight, or the meanings they attached to their shelter. What we can say, humbly, is that the evidence they left behind complicates and enriches our understanding of the peopling of the Americas. It forces us to accept that the story is older, longer, and more intricate than once believed. Meadowcroft, in its quiet way, refuses to let the conversation end. It insists that prehistory in North America cannot be reduced to a single culture or a single moment, but is instead a tapestry woven across thousands of years, with this sandstone overhang serving as one of its oldest surviving threads. Were people carving tools in South Carolina long before the Clovis toolkit appeared? Along the Savannah River in Allendale County lies a sandy terrace known as the Topper Site. To the casual eye it is nothing extraordinary, but beneath its surface archaeologists have unearthed evidence that continues to stir debate about the antiquity of human presence in the southeastern United States. Topper is one of those places where science collides with controversy, where ordinary flakes of stone might either rewrite history or be dismissed as meaningless. The site was excavated extensively by archaeologist Albert Goodyear beginning in the 1980s. In its upper layers, Topper yielded familiar Clovis points, those finely fluted spearheads that once defined the first Americans. But as excavation deepened, something unusual emerged. Beneath the well-known Clovis horizon lay thousands of stone artifacts, small flakes, blades, and cores, that seemed to predate Clovis by thousands of years. Some were found in sediments dated to as early as 16,000 years ago, and Goodyear and his team even suggested that some deeper deposits might reach as far back as 50,000 years, though those claims remain highly controversial. What makes Topper puzzling is the character of its artifacts. Unlike the elegant symmetry of Clovis points, the pre-Clovis assemblage here is dominated by tiny flakes and rudimentary tools, sometimes described as microlithic. To the untrained eye, they can look indistinguishable from natural rock fractures. Critics argue that many of the so-called artifacts could simply be geofacts, bits of chert broken by natural processes rather than by human hands. Supporters counter that the sheer concentration of flakes, the presence of cores, and the context of their deposition point strongly to deliberate napping. Adding intrigue is the possibility of early symbolic behaviour. Some pieces of chert from the lower levels appear to have incised marks that may represent intentional engraving. While far from definitive, these scratches have fueled speculation about whether the inhabitants of Topper engaged in early forms of expression or record-making. If true, it would push back not only the technological, but also the cognitive footprint of humans in the Americas. Yet here again, the line between human and natural origin is razor-thin, and the evidence remains contested. Regardless of where one stands on the earliest dates, Topper matters because it broadens the geographical scope of the pre-Clovis debate. Most discussions focus on the west, with sites like Buttermilk Creek, Meadowcroft or Monte Verde dominating the conversation. Topper shifts attention to the southeast, reminding us that the search for early Americans cannot be confined to a single region. The sandy terraces of the Savannah River may have been attractive to ancient people for the same reasons they appeal to archaeologists today. Abundant chert for tool-making, access to fresh water, and proximity to diverse ecological zones. The controversy surrounding Topper also highlights an enduring challenge in archaeology: how to distinguish genuine human activity from the noise of geology. Nature is a relentless napper. Rivers tumble stones, fires crack them, and pressures within the earth fracture them in ways that can mimic human work. To prove authenticity requires not just a single artifact but patterns, cores showing reduction, refits of flakes to a parent stone, and concentrations that exceed chance. At Topper, many experts remain divided over whether the lower-level material meets that standard. Yet even if the earliest claims remain uncertain, the evidence from about 16,000 years ago is harder to dismiss. Radiocarbon dates from associated charcoal and the consistent presence of non-Clovis tools make it clear that people were in the southeast before the Clovis horizon. That alone is significant. It means that populations were spreading rapidly into diverse environments, from the arid plateaus of Texas to the humid woodlands of South Carolina, well before the once sacrosanct Clovis timeline. The haunting question Topper leaves us with is not just whether humans were here earlier than expected, but how we decide what counts as proof. Do we demand elegant points and indisputable craftsmanship, Or do we accept that the earliest toolkits may have been humble, crude, and easy to overlook? If we require perfection, we may erase the traces of those first fragile footholds. If we accept too much, we risk building history on shadows. Topper sits in that uneasy middle ground, reminding us that the truth of the first Americans may lie not in spectacular discoveries, but in the stubborn accumulation of small, contested fragments, waiting for us to look closely enough to see the human hand behind them. If there is one lesson that Topper forces upon us, it is the humility of scale. For much of the 20th century, American prehistory was imagined in terms of grand hunts and iconic weapons, towering mammoths brought down by spears tipped with masterfully shaped Clovis points. In contrast, Topper whispers rather than shouts. Its record is built from small flakes, tiny blades, and possible engravings that require magnification and patience to appreciate. Yet it may be precisely this modesty that makes it important. The earliest people in a new land may not have had the leisure to create symmetrical masterpieces. They might have carried only the simplest tools needed to survive, leaving behind evidence so minimal that later generations of archaeologists nearly missed it. Another dimension to consider is how sites like Topper broaden our picture of early adaptations in different environments. In South Carolina, the landscape was nothing like the steppes of Alaska or the bogs of southern Chile. The Savannah River Valley offered a mix of pine forest, hardwood stands, and riverine wetlands. In such a setting, big game hunting would not have been the only strategy. Gathering edible plants, fishing, and trapping smaller animals would have been just as essential. The tiny flakes found at Topper may reflect tasks like cutting reeds, scraping hides, or shaping wood rather than dispatching massive herbivores. It hints at a daily life less glamorous than mammoth hunts, but no less central to survival. The potential antiquity of Topper also nudges us toward a broader reconsideration of how quickly people spread once they reached the Americas. If humans truly occupied this part of the southeast by 16,000 years ago, or even earlier, as some claims suggest, then the rate of dispersal was astonishing. Within a few millennia of crossing into the continent, groups would have fanned out thousands of kilometres, adapting to deserts, grasslands, coastal estuaries, and forested river valleys. This speed of adaptation speaks to a flexibility deeply ingrained in our species. Still, Topper is not just a story of dates and flakes. It is also a story of controversy, and of how science moves forward in fits and starts. Albert Goodyear's announcements of extremely early occupation were met with skepticism, even ridicule by some of his peers. Conferences grew heated, with debates hinging on whether a sliver of chert bore the unmistakable hallmarks of human intent. Over time, as more refined studies emerged and as radiocarbon dates accumulated, the conversation cooled somewhat, but Topper remains a contested site, and perhaps that is as it should be. In a field as delicate as early American archaeology, disagreement is not a failure but a sign of seriousness. It is a reminder that extraordinary claims are not dismissed lightly, but must weather years of scrutiny before gaining acceptance. Beyond its scientific implications, Topper also underscores how fragile archaeological evidence can be. The site rests on river terraces that have been shaped and reshaped by water flow for thousands of years. That anything survived at all is remarkable. Countless other occupations may have been erased by erosion, flooding, or sediment burial, leaving us with only fragments of the fuller story. When we gaze at the modest flakes from Topper, we should remember that they may stand in for an entire vanished record, the barest remnants of lives once lived along the Savannah River. In the end, Topper teaches us patience. Whether or not the deepest levels truly push human presence back to 50,000 years ago, the evidence from the upper Pre-Clovis layers already tells us something vital. That people were present in the southeast earlier than the traditional model allowed. It reminds us that history is not rewritten in a single dramatic discovery, but through the slow layering of possibilities, the steady testing of claims, and the willingness to keep listening when a site refuses to be silent. Topper, aptly, is the rock shelter that would not shut up. Did America's earliest settlers already know how to sail? To many scholars in the mid-20th century, the idea would have seemed unlikely. For decades, the dominant image of Ice Age migration into the Americas was that of people trudging on foot across a frozen land bridge, armed with spears following herds of mammoths and bison. Boats were left to later eras, to Polynesian explorers or Norse voyagers. But then the evidence began to wash ashore in the most unlikely of places, a string of islands off the coast of California, where the Pacific Ocean once ran far lower and the land stretched much farther out to sea. These were the Channel Islands, and their archaeology forced a reconsideration of what humans were capable of long before Columbus or even the Vikings. The Channel Islands lie today about 40 kilometres offshore, though in the late Pleistocene that distance was narrower, perhaps only a few kilometres at its shortest. Even so, there was no way to reach them without crossing water. People had to have used some form of watercraft, rafts, dugouts or skin boats, to settle these islands and exploit their resources. Excavations there have uncovered barbed projectile points, fishing gear, and middens stuffed with the remains of shellfish, seabirds and marine mammals. Far from being stranded or isolated, the islanders thrived on a maritime economy. The tools themselves are telling. The barbed points, sometimes described as stemmed or shouldered, were ideal for spearfishing and sealing. Their presence in context, dated to around 12,000 years ago, demonstrates a clear adaptation to coastal life. Archaeologists have found these points alongside the bones of fish, sea otters, cormorants, and even small whales. People were not merely scavenging what washed up, but actively harvesting from the sea. Combined with evidence of seaweed consumption and use, the picture that emerges is one of communities deeply tied to the rhythms of marine ecosystems. What makes the Channel Islands especially important is how their record connects with the broader debate about coastal migration. If people were thriving on islands off California 12,000 years ago, there is every reason to think that their ancestors had been skilled in seafaring for millennia beforehand. You do not simply invent maritime lifeways overnight. The knowledge of tides, currents, and the behaviour of marine animals takes generations to accumulate. This supports the so-called 𝐓𝐈𝐌𝐿 hypothesis, which argues that the first settlers of the Americas moved south along the Pacific coast, hugging a corridor rich in kelp forests and their abundant resources. Of course, as with all things in archaeology, the story is not without controversy. The watercraft used by these early mariners have not survived. Organic materials like wood, hide, or fibre rarely endure thousands of years in the archaeological record. Critics note that the Channel Islands might represent a later innovation rather than an echo of the earliest migrations. Still, the circumstantial evidence is compelling. The islanders were not simply fisherfolk of convenience, but expert seafarers whose lives revolved around the sea. What haunts us about the Channel Islanders is the unanswerable question of how far their boats might have carried them. Were they content with the short crossings to and from the mainland, or did they push farther, exploring other stretches of the Pacific coast? Did knowledge of sailing filter inland, shaping trade and movement networks along rivers as well? We cannot say for certain. What we can say is that by at least 12,000 years ago, some of the earliest Americans were not just walkers of land, but riders of waves, their horizons stretching as wide as the Pacific itself. When we try to imagine the first people pushing boats out into the Pacific swells, it is worth asking how they acquired such knowledge in the first place. Humans had been exploiting shorelines for tens of thousands of years elsewhere in the world. Evidence from Southeast Asia and Australia demonstrates that people were capable of sea crossings by at least 50,000 years ago, long before the Americas came into view. By the time humans reached the North Pacific, they likely already carried with them a toolkit of maritime practices: how to lash together logs, how to waterproof hide-covered frames, how to read the surface of the ocean for signs of fish or dangerous currents. In other words, the Channel Islands may not represent a sudden invention of seafaring, but the continuation of an older tradition transplanted into new waters. The ecological setting of the islands also matters. The kelp forests of the California coast are among the most productive ecosystems on Earth. They host fish, shellfish, sea otters, pinnipeds, and seabirds in dizzying abundance. For small groups of hunter-gatherers, these kelp forests were not obstacles but larders waiting to be opened. And unlike large land mammals which migrated seasonally and required dangerous hunts, the sea's resources were replenished constantly. Shellfish could be gathered at low tide, fish speared from the shore, seaweed cut and dried for storage. The archaeological middens brimming with marine remains show that the islanders understood this abundance intimately. Living on an island, however, came with constraints. Freshwater was limited, and terrestrial game was scarce. This meant that the Channel Islanders had to maintain steady connections with the mainland, not only to exchange goods, but also to preserve social ties. Crossing back and forth would have become routine, as ordinary to them as walking a trail. It is easy to forget how much knowledge such routines require, understanding weather patterns, reading stars and coastlines, and knowing how to balance loads in a canoe or raft. Their survival depended on turning the sea into something navigable, not forbidding. There is also a cultural dimension. Maritime societies often embed the ocean into their identities. While we lack the oral traditions of the Channel Islanders, it is tempting to wonder what stories they told about the sea, what rituals might have accompanied the launch of a boat, or what meanings they attached to the animals they harvested. The barbed points themselves might be more than functional tools. They may represent standardized designs taught across generations, a kind of shared technological language that marked them as members of a seafaring community. The implications ripple outward. If people could establish permanent lifeways on the Channel Islands 12,000 years ago, then earlier groups moving south along the Pacific Rim may have used similar strategies. Hidden now under meters of ocean, their campsites along ancient shorelines would have told us whether the Channel Islanders were late adopters or simply the survivors of a much older maritime tradition. The absence of such evidence does not mean it never existed, only that the sea has swallowed it. So when we look at the Channel Islands, we are not just studying isolated campsites, we are glimpsing a coastal legacy that may have stretched from Alaska down to Chile. The boats themselves are gone, their wood rotted, their hides dissolved, but the consequences remain. Populations capable of rapid dispersal, cultures willing to gamble on the open water, and evidence that the Americas may have been settled as much by paddles and tides as by footsteps across tundra. The haunting question is not whether these early people sailed, they clearly did, but how far and how soon that skill carried them into the unknown. Can fossilized human poop settle a 13,000-year-old argument? That is the unlikely but very real question posed by the archaeology of the Page-Ladson Caves in Oregon's high desert. For generations, the debate over the first Americans revolved around spear points, bones, and radiocarbon dates. But in the early 2000s, the focus shifted to something more humble, more intimate, and much harder to argue away: coprolites. These dried, fossilized remains of human digestion became some of the most important evidence in overturning the idea that the Clovis culture represented the continent's starting line. The Page-Ladson Caves are a series of small volcanic rock shelters overlooking a stark basin and range landscape. To a casual visitor, they are unremarkable. Yet tucked within their dusty sediments were layers of material that told a story of survival in the American West at the very end of the Ice Age. Archaeologists led by Dennis Jenkins of the University of Oregon carefully excavated the caves, using modern techniques that previous generations could only dream of. Their finds included not only stone tools but also bone, plant remains, and, most unexpectedly, human coprolites preserved in the dry cave floor. Why are these coprolites so important? Because they contain DNA. In multiple samples dated to about 14,000 years ago, researchers were able to extract mitochondrial DNA that was unmistakably human. This meant that people were living in the caves at least a millennium before the appearance of the Clovis toolkit elsewhere. To strengthen the case, the team took rigorous precautions to avoid contamination. The DNA of every field worker was sequenced, so that any accidental introduction of modern genetic material could be ruled out. The results held up, convincing many skeptics that the coprolites were genuine traces of pre-Clovis Americans. The tools found in the Page-Ladson Caves were not Clovis points, but part of what archaeologists call the Western-stemmed tradition. These points have stems or tangs at their bases, allowing them to be hafted into shafts, but they lack the fluting that defines Clovis. Radiocarbon and luminescence dating demonstrated that the Western stem tradition overlapped in time with Clovis, meaning that two distinct technological traditions coexisted in North America more than 13,000 years ago. This shattered the simple narrative of a single founding culture. Instead, it suggested that different populations, perhaps with different ancestries and different routes of arrival, were already adapting in their own ways to the diverse environments of the continent. The Page-Ladson evidence also underscores the value of looking beyond flashy finds. For years, the archaeological community focused heavily on large showpiece sites with dramatic artefacts. Coprolites are not glamorous. They are the sort of discovery that might elicit a chuckle or a grimace, yet they preserve a direct, unbroken line to human presence that no spearpoint can match. They contain not only DNA, but also chemical traces of diet, parasites, and microbiomes, painting a picture of everyday life that is often missing from stone tool assemblages. What remains unresolved is how the people of Paisley fit into the broader map of early American settlement. Were they descendants of coastal migrants who pushed inland? Did they represent an independent population with roots in an earlier migration? The DNA cannot yet tell us everything, but it can tell us that they were there, real people leaving behind the least likely of legacies. The haunting question the Page-Ladson Caves pose is not just whether humans were here before Clovis, but how many parallel stories we have lost because the evidence was too fragile or too humble to be preserved. If coprolites can rewrite textbooks, what other ordinary traces, ashes from hearths, scraps of fibre, a child's footprint, might still wait to be noticed in the dust of America's deserts? The story of Paisley does not end with a few coprolites and some stemmed points. What makes the cave so influential is how they forced the field of archaeology to refine its methods. In the late 20th century, a site claiming to predate Clovis often faced withering skepticism, not always without reason. Many earlier claims were weakened by poor excavation standards, ambiguous artifact identification, or inadequate dating. At Paisley, Jenkins and his team insisted from the start on meticulous protocols. Samples were bagged and labelled with extraordinary care. Contamination controls were rigorous, and every claim was backed by multiple lines of evidence. This was more than an excavation. It was an attempt to create a bulletproof case for pre-Clovis occupation in North America. The DNA evidence was certainly the headline, but the stone tools were no less important. The western stemmed points found in the caves connect to a wider tradition across the Great Basin and Pacific Northwest. These points suggest an adaptation tailored to smaller game, fishing, and mixed subsistence, rather than the large animal focus that is so often associated with Clovis. When combined with the faunal remains from Paisley, which include waterfowl and small mammals, the impression is of a community finely tuned to a desert basin environment, rather than pursuing mammoth herds. This expands our understanding of what Ice Age life in North America could look like. Beyond subsistence, the Page-Ladson Caves also hint at the resilience of human groups in marginal landscapes. The high desert of Oregon is an austere environment, marked by sharp seasonal swings and scarce water sources. Yet the presence of repeated occupation layers shows that people did not just pass through, but returned, generation after generation. They knew where to find water, how to store food, and how to maintain a living in conditions that many today would find forbidding. Such persistence suggests that the first Americans were not simply opportunistic migrants, but people capable of establishing footholds in some of the continent's most demanding settings. What makes Paisley so haunting is how it reframes the broader picture of early settlement. If humans were thriving in Oregon's interior 13 or 14,000 years ago, then they must have been established elsewhere long before. It takes centuries to develop tool traditions, social knowledge, and ecological familiarity. This means that by the time these coprolites were deposited, America's first peoples were already generations deep into their new worlds. They were not explorers on a brief expedition. They were rooted communities. One of the lasting legacies of Paisley is the way it shifted the conversation from whether pre-Clovis people existed to how many different traditions coexisted. Clovis may have been widespread, but it was not alone. Western STEM technologies, perhaps coastal adaptations, and possibly other yet undiscovered traditions were all unfolding simultaneously. This multiplicity tells us that the settlement of the Americas was not a single dramatic migration, but a web of movements, experiments, and adaptations. For archaeologists, the Page-Ladson Caves remain a lesson in humility. They remind us that the most unassuming traces, scraps of fibre, the residue of a meal, even the waste of digestion, can overturn entrenched dogmas. They challenge us to keep an open mind, to resist neat, singular stories, and to accept that the past is rarely as tidy as the models we use to explain it. The coprolites from Paisley are not glamorous, but they are enduring. They whisper across 13 millennia that real people lived, ate, and endured here, long before textbooks allowed them to, and their very ordinariness may be the most powerful evidence of all. What happens when a mastodon bone has a spear tip stuck in it? For decades, the Manus site in Washington state carried that strange, unsettling question at its heart. In 1977, farmer Carl Gustafson uncovered the partial skeleton of a mastodon while digging a pond near Sequim on the Olympic Peninsula. Among the bones lay a rib with an odd puncture. Embedded deep inside the wound was a fragment of material that appeared foreign to the mastodon's own anatomy. Gustafson suspected it was a projectile tip, evidence of human hunting, but his claim was met with skepticism. The date he suggested, around 13,800 years ago, was older than the accepted Clovis timeline, and the supposed spear point was made not of stone but of bone. To many in the archaeological establishment it sounded too radical, too messy, and too early. For more than 30 years the Manus rib remained in limbo. Some scientists dismissed the puncture as an injury caused by another mastodon's tusk, or a natural break that happened long after burial. Others considered Gustafson's interpretation possible but unproven. The fragment inside the rib was too small and too difficult to analyse with the techniques available at the time. Without definitive evidence, the Manus site became one of those murky cases that hovered on the margins of the Clovis first debate. Interesting, but not conclusive enough to overturn orthodoxy. That began to change in the 21st century, when advances in accelerator mass spectrometry, AMS, and imaging technology made it possible to test Gustafson's hunch. Researchers returned to the rib, extracting samples of collagen for radiocarbon dating. The result confirmed a startling age, about 13,800 years old, several centuries before the earliest secure Clovis sites. Then came micro-CT scans, which allowed scientists to peer inside the rib without destroying it. The scans revealed that the embedded fragment was indeed shaped by human hands. It was carved from another mastodon's bone, and had been intentionally sharpened into a point. This meant that a hunter, standing somewhere on the Olympic Peninsula nearly 14 millennia ago, had fashioned a weapon from the remains of one animal, and used it to pierce the body of another. The impact drove the projectile so deep that the bone grew partially around it, suggesting the mastodon survived for some time after the injury before eventually dying. For archaeologists, it was a revelation. Not only were humans present in the Pacific Northwest before Clovis, but they were hunting enormous Ice Age mammals with sophisticated bone weaponry. The implications ripple outward. The Manus site demonstrates that bone technology, often invisible in the archaeological record because of its tendency to decay, played a crucial role in the development of human civilization role in early American lifeways. It also shows that pre-Clovis peoples were not merely opportunistic scavengers, but capable hunters who could take down or at least wound massive creatures weighing several tons. This challenges the notion that complex hunting strategies arrived suddenly with Clovis and instead suggest a deeper tradition of ingenuity. Perhaps the most haunting aspect of the Manus rib is its silence. No stone points lie scattered nearby, no hearths or living floors. All we have is one mastodon, one rib, and one weapon lodged within it. From this single wound we are forced to reconstruct entire worlds. The hunters who tracked the animal, the decision to use a bone-tipped spear rather than stone, the tense moment of attack. The Manus rib reminds us that history often survives in fragments, and that sometimes one broken bone is enough to redraw the map of human presence. The rib from Manus, as quiet as it may seem, has forced archaeologists to rethink what kinds of evidence they are willing to accept as valid. For decades, the discipline leaned heavily on lithics, stone tools, as the gold standard of proof. Stone preserves well, stone is unambiguous when flaked, and stone artifacts can often be directly tied to cultural traditions. Bone, by contrast, is fragile, porous, and prone to decay or distortion. A chipped flake of chert can survive untouched for 20,000 years, but a sharpened fragment of bone may dissolve in a single wet season. This bias towards stone meant that entire aspects of early technologies went unnoticed or were dismissed. The Manus rib reintroduced the uncomfortable reality that many of the earliest tools were likely made from organic materials that rarely survive. This has broader implications for how we interpret the archaeological record. If the first Americans used bone, wood, fibre, and hide as much as stone, then the absence of these materials leaves us with only a sliver of their world. The Manis discovery, with its carved Mastodon bone point, suggests that what little survives may only hint at a far richer technological toolkit. Hunters who could carve bone projectiles could just as easily weave nets, build rafts or craft snares, none of which would leave much trace in sediments after thousands of years. It forces us to accept that the absence of evidence is not the evidence of absence, a mantra repeated often in science, but easy to forget when working with sparse data. Another aspect often overlooked is the ecological drama hidden inside that single rib. A wounded mastodon carrying a human-made spear tip in its side is not just a static artifact. It is a record of encounter, of risk, of a calculated gamble between predator and prey. The hunters would have faced a towering animal armed with tusks and mass, one capable of killing with a single charge. Choosing to engage it implies both desperation and skill. Perhaps they aimed to finish it off later, trailing the animal over days until exhaustion set in. Or perhaps the strike failed, leaving only a scar in the rib as the mastodon escaped. Whatever the outcome, the embedded point preserves the drama of a confrontation that happened in deep prehistory. The rib also offers a glimpse of the social scale behind such hunts. Bringing down an Ice Age elephant was not the work of a lone hunter. It required coordinated groups, knowledge of animal behaviour, and strategies honed over generations. The presence of a crafted projectile embedded so deeply suggests intentional planning, the kind of cooperation that defines Homo sapiens across continents. The Manis hunters were no less human in their tactics than the people who, millennia later, would devise elaborate drives for bison on the Great Plains. The continuity across time is striking, humans shaping their environment by working together against formidable prey. There is a final, almost philosophical lesson in the Manis rib. For years it sat as an enigma, too ambiguous for some, too bold for others. It teaches patience. Archaeology is not a science of instant revelations, but of fragments slowly accumulated, revisited with new methods, and reinterpreted in light of fresh perspectives. The fact that modern scanning and dating technologies could extract so much clarity from a fossil discovered in the 1970s reminds us that the record is not fixed. Each generation of scientists can return to old evidence with new tools, and in doing so, peel back another layer of the past. The mastodon rib with its hidden point is therefore not just a piece of bone. It is a reminder that history waits in silence until the questions are right and the methods are ready. Did Ice Age Europeans really sail across the Atlantic before Clovis? The idea is tempting, not least because it makes for a dramatic headline. Hardy hunters from the edge of Ice Age France or Spain, setting out beneath the Atlantic ice shelf and washing up in North America thousands of years before Columbus. This is the so-called Solutrean hypothesis, proposed in the late 20th century and gaining wider attention in the early 2000s, when archaeologists Dennis Stanford and Bruce Bradley argued for a direct cultural link between Europe's Solutrean toolmakers and the Clovis people of North America. On the surface, the argument seems straightforward. Both traditions produced thin, elegant projectile points, and both employed a flaking method known as overshot or outre-passé flaking, where a chip is struck across the face of a stone so aggressively that it flakes off the opposite edge. To some eyes, the similarity was too striking to be coincidental. If Clovis points appeared in America around 13,000 years ago, and Solutrean points existed in Europe from about 24,000 to 17,000 years ago, perhaps one evolved into the other by way of a transatlantic migration. The reveal, of course, is that almost nothing else fits. For one, the two tool types are not as similar as enthusiasts suggest. Clovis points are distinctively fluted, with a channel flake removed from the base to help haft them onto spear shafts. Solutrean points lack this feature entirely. Their overall shapes differ, their sizes vary, and their contexts are not interchangeable. Even the technique they supposedly share is not unique. Overshot flaking has cropped up independently in other times and places around the world. Convergence in technology does not require shared ancestry. It requires similar material challenges, and sharp stones provide plenty of those. When we press further into the evidence, the gaps widen. No Solutrean sites have been found on the American side of the Atlantic. None of the associated cultural baggage of Solutrean life, art, symbolic carvings, bone and antler technologies appear in North American contexts. The chronological problem is even more severe. If solitary hunters really crossed the Atlantic around 18,000 years ago, why do Clovis points only appear in America thousands of years later? The supposed parent technology would have lain dormant for millennia, before blossoming into its descendant, an unlikely sequence in archaeology. Genetics adds another nail to the coffin. The mitochondrial DNA haplogroup, sometimes cited as evidence of European ancestry in Native Americans, known as haplogroup X, turns out not to be a solitary signature at all. The form found in the Americas, X2A, is genetically distinct from the forms common in Europe, and its deeper ancestry lies in populations of Western Asia. In other words, both Europeans and Native Americans inherited it from earlier Eurasian groups rather than from a transatlantic voyage. The cousin relationship of these lineages does not imply direct parentage. There is also the practical issue of survival. Crossing the Atlantic at the height of the last ice age would have meant navigating a treacherous ocean covered in seasonal ice flows, with no known evidence of solitary watercraft capable of such journeys. These people were skilled hunters of reindeer and horses on land, and while they may have exploited coastal resources, there is no indication they were open ocean mariners. By contrast, we know with confidence that humans had already reached Australia by boat tens of thousands of years earlier. The capacity to cross smaller tropical seas is plausible. The leap across an icy Atlantic stretches credibility. Still, it is important to treat even unlikely hypotheses with respect, because they highlight the gaps in our knowledge and push us to test assumptions. The solitarian idea caught attention partly because it challenged the rigid Clovis first orthodoxy that dominated for so long. By raising the possibility of earlier, different migrations, it helped clear space for serious consideration of sites like Monte Verde or Buttermilk Creek. Ironically, though the hypothesis is almost certainly wrong, it contributed to loosening the intellectual stranglehold of Clovis as the one true beginning. The solitarian story also reveals something about how archaeology is consumed by the public. A tale of Europeans discovering America before anyone else has a certain cultural allure, especially in societies already used to celebrating Columbus or Norse voyages. But it risks overshadowing the deeper, more complex reality. The Americas were peopled by migrants from Asia, not from Europe, and the process involved multiple stages, bottlenecks, and adaptations across tens of thousands of years. Clinging to the solitarian idea can inadvertently diminish the rich record of indigenous origins and survival. In the end, the solitarian hypothesis is best understood not as a viable explanation, but as a reminder that similarities in artifacts are not enough. Convergence happens, coincidences happen, and human ingenuity is rarely confined to a single pathway. The solitarians carved their leaf-shaped points in Ice Age Europe. The Clovis people fashioned their fluted blades on American plains. They were separated by an ocean, by thousands of years, and by the independent unfolding of human imagination. What unites them is not ancestry, but the shared human drive to solve problems with whatever stone was at hand. The haunting question remains: how many other parallel traditions once existed that we may never see, erased by time, leaving behind only fragments and the temptation to draw lines between them? What do genetics say about people who came to the Americas and vanished? This question pushes us into one of the strangest territories in the study of early migrations: the existence of ghost populations. These are groups whose traces linger in DNA but who leave behind no material culture that we can confidently tie to them, no obvious descendants who carry on their identity, and sometimes not even a name beyond the letters geneticists assign to them. They are reminders that prehistory is not a clean lineage of survival, but a tangled web of arrivals and disappearances. For every group that endured, others left only faint echoes in genomes or were erased entirely by time. One of the most intriguing of these mysteries is called Population Y, not because anyone knows much about them, but because the name was chosen as a placeholder. In the mid-2000s, geneticists analysing the genomes of certain indigenous peoples in the Amazon basin noticed something startling. A tiny percentage of their DNA seemed to link more closely with populations from Australasia, groups in places like Papua New Guinea and the Andaman Islands, than with their Native American neighbours. This did not mean that ancient Australians paddled across the Pacific in one heroic leap, but it did suggest that some population carrying these genetic signatures once made its way into the Americas, mixed with the ancestors of certain South Americans, and then largely disappeared. The haunting part is that we have no physical record of population Y. No sites, no tools, no burials clearly tied to them. They exist only in the statistical whispers of genomes, teased out by comparing the probability that certain DNA sequences match one lineage over another. And even here, the signals are faint, debated, and often dismissed by more cautious scholars. Still, the pattern is held up across different analyses. Something in the ancestry of the Amazon points to a connection outside the standard story of migration through Beringia. Was this an ancient subpopulation in Northeast Asia that carried Australasia-like DNA and moved into the Americas before disappearing? Was it a failed colonization, a lineage that was absorbed and lost as population shifted? We do not know. Another puzzle comes from what researchers call the unsampled population A. Unlike population Y, which leaves its trace in the deep Amazon, population A appears in genetic analyses of indigenous groups in Mexico. These lineages do not match the known branches of northern or southern Native American ancestries. Instead, they suggest that some group, now vanished, entered the Americas and left fragments of their DNA behind. The timing of this arrival is uncertain, but models hint it may have been after the Last Glacial Maximum, perhaps around 9,000 years ago. If so, then this was not part of the earliest migrations, but a later pulse of people moving into an already inhabited land. Yet again, no archaeological culture can be definitively tied to them. They are known only as a statistical ghost. And then there are the ancient Beringians, a group who remind us that not all ghost populations lived south of the ice. These people, identified from the remains of infants buried at the Upward Sun River site in Alaska, split off early from the ancestral Native American lineages. They were distinct, genetically identifiable, and clearly present in eastern Beringia thousands of years ago. But unlike the branches that gave rise to modern native peoples, the ancient Beringians left no direct descendants. Their lineage seems to have been absorbed or replaced, another case of disappearance in plain sight. For decades, we imagined Beringia as a simple waiting room for the Americas. The ancient Beringians remind us it was also home to people with their own stories, most of which are lost. These ghost populations challenge our sense of narrative closure. We want the story of the first Americans to be clean, a migration, a dispersal, a continuity into the present. But science keeps showing us that human history is not a straight line. It is layered, interrupted, and haunted. Populations rise, expand, mix, and vanish. Some leave tools we can hold in museums, others leave only shadows in genomes. All remind us that we are looking at the past through a keyhole, piecing together the story of humanity with fragments that survived by chance. The haunting question is how many more ghost populations once walked the Americas, entirely invisible now, they only trace the silence they left behind. Before we descend into the genetic shadows, it helps to pause and consider what it even means to lose a population. In popular imagination, extinction is final and absolute. Yet in human prehistory, disappearance is more subtle. A group might vanish without ever being eradicated because their genes can be swallowed up into others, diluted until their unique identity is indistinguishable. Cultures can dissolve into neighbours, languages can be forgotten, traditions can be absorbed and reshaped. When archaeologists or geneticists describe a ghost population, they are not always describing a people who perished, but a people whose boundaries blurred beyond recognition. This is a reminder that identity is fragile, and that the record we reconstruct today is shaped as much by silence as by survival. The problem of detection is sharpened by the quirks of preservation. Archaeological traces are capricious. Bones dissolve in acidic soils. Tools may lie undiscovered beneath meters of sediment, and whole coastlines that once supported thriving communities are now drowned under the sea. Genetic evidence is even more precarious. Ancient DNA degrades quickly, especially in hot and humid regions, which is precisely where some of these mysterious signals are strongest. The result is a puzzle where most of the pieces are missing, and we are left with tantalizing fragments that hint at bigger pictures we cannot yet see. When researchers speak of population Y in the Amazon, for example, what they are really reporting is a statistical curve, a signal so faint that it takes large-scale modelling to even notice it. That such whispers can still be heard through thousands of years of genetic drift tells us how deep and old these connections must be. There is also the issue of scale. Ancient migrations were rarely grand sweeping events of thousands of people marching in lockstep across continents. More often, they were small exploratory movements, families, bands, clusters of travellers who may have joined established groups, mixed, and then disappeared as discrete entities. If one of those small groups carried unusual DNA, its presence might echo faintly in the future, but not persist in full. The very process of mixing makes ghost populations almost inevitable. They remind us that the Americas, like everywhere else, were not settled in a single wave but in a mosaic of movements, some of which burned brightly, and some of which flickered out almost unseen. Anthropologists sometimes describe this as the palimpsest effect. Imagine a parchment reused again and again, with older writing scraped away and new words layered on top. In certain light, traces of the old text can still be glimpsed. The genomes of modern populations are like this, carrying visible signatures of recent ancestry, but also faint shadows of groups long gone. Every new analysis, every ancient bone that yields DNA, adds another stroke of illumination to the parchment. But no matter how much light we shine, there will always be lines that are too faint, too eroded, to ever be read again. All of this raises a haunting question. If we can detect population Y in the Amazon, unsampled population A in Mexico, and ancient Beringians in Alaska, despite the overwhelming odds stacked against preservation, how many more ghost populations remain entirely invisible? How many groups lived in valleys now flooded, or on plains never excavated, or in climates where no bone or genome could survive? We will likely never know their names or their stories. Yet they were real as the ones who did endure, and they remind us that the story of the settlement of the Americas is not just one of arrival, but also of erasure. It is this balance between presence and absence, between what we can know and what we can never recover, that makes studying ghost populations both frustrating and strangely comforting. They tell us that humanity's past is far richer than any neat diagram can convey, and that every map of migration is always incomplete. They invite humility, the recognition that science cannot give us all the answers, but it can at least show us the outlines of mysteries worth contemplating. What is the haunting question that keeps archaeologists up at night? It is not so much the desire to know the precise date when the first footprints touched American soil, nor to win an argument about which theory of migration deserves supremacy. What gnaws at researchers is the immensity of what remains unseen. For every site we uncover, for every genome coaxed from ancient bone, we are reminded of 100 others erased by floods, buried beneath sediments, or lost beneath the sea. The Americas, more than any other part of the world, hold their earliest stories in places that are now inaccessible, drowned under coastlines that once offered shelter, food, and pathways for movement. Until the tools of underwater archaeology are more fully realised, until we invest the resources to map those hidden shelves and drowned valleys, the first chapters of the settlement of these continents will remain shrouded. There is also the quiet acknowledgement that even if we excavated every cave and dredged every ancient shoreline, the story would still resist completion. Human history is not a puzzle with every piece preserved. It is closer to a manuscript copied and recopied, some passages fading, others rewritten, whole chapters missing altogether. This is why each new discovery feels less like final proof and more like a glimpse through a keyhole into a room we cannot fully enter. White sands gave us footprints, but not the lives that made them. Genetic models reveal ghost populations, but not their names, languages, or songs. Bluefish caves yield cut bones, but not the voices of those who napped tools in the cold. We hold fragments and must build a narrative around absence as much as presence. What unsettles scientists most is how rapidly the narrative changes with each new piece of evidence. A single footprint layer, a redated tusk, a new genome from an unexpected location. Any one of these can tilt the timeline, redraw the migration map, or overturn what had seemed like consensus. For students and the public, this can appear frustrating, as though archaeologists cannot make up their minds. But this is the essence of science, to embrace uncertainty, to revise when new data demands it, and to resist the comfort of neat answers when the evidence points elsewhere. The settlement of the Americas is a story where humility is not optional but necessary. It also raises a deeply human reflection. Why do we care so much about who the first Americans were, when they came, and how they arrived? Part of the answer lies in identity. For indigenous peoples, these are ancestral questions that connect living communities to deep time. For scientists, they are intellectual challenges that stretch the limits of method and theory. But for all of us, they are existential. The Americas were the last great landmass settled by humans, the last continent to receive our restless wandering. In that fact lies a mirror. The first footsteps into these landscapes were the final strokes in a painting begun in Africa 100,000 years earlier. To study them is to study not just archaeology, but the completion of humanity's global journey. And so the haunting question is less, when did it happen, than what does it mean to never know everything? Perhaps the oldest migrants left no descendants, their stories erased except for a trace in DNA or a broken tool. Perhaps some coastlines still hide evidence that would rewrite the textbooks once again. Or perhaps the greatest lesson is that absence itself is part of history, that forgetting is as human as remembering. Archaeologists are often accused of chasing shadows, and in a way that is true, yet shadows tell us that something once stood in the light. In the end, the settlement of the Americas is a reminder that the human story is never final. It is written in footprints that fade, in bones that crumble, in genomes that whisper. What we know today may shift tomorrow. What we believe settled may be unsettled again. This uncertainty is not failure. It is the beauty of science, to accept mystery not as a gap to be ashamed of, but as a space of curiosity, an invitation to keep asking, and perhaps that is the truest comfort. The first Americans may have walked here 30,000 years ago, or 20,000, or 15. The exact number matters less than the recognition that the story remains alive, unfolding, and incomplete. The haunting question that keeps archaeologists awake is also the one that should help the rest of us sleep. How little we know, and how wondrous it is that even in our ignorance we can still glimpse the immensity of human persistence. The Americas, like all of humanity, were not settled once but again and again, in movements visible and invisible, remembered and forgotten. We are the descendants of survival, but also of disappearance. To study this is not just to learn history, but to learn humility. What lingers, after all the radiocarbon charts and contested tool fragments, is not only the thrill of discovery, but the sobering weight of how much we cannot yet see. When archaeologists today speak of the settlement of the Americas, they do so knowing they are peering through a keyhole into a cathedral. The outlines are there, broad enough to sketch, yet the details recede into darkness. Each new discovery seems to push the door open a little wider, and yet the vast interior remains out of reach. That is not failure. It is the nature of this kind of science. It is an inquiry built on patience and on the acceptance that some answers may take decades, or may never come at all. One of the starkest reminders of this incompleteness is the ocean itself. During the periods when humans were first moving into the Americas, sea levels were far lower. Entire coastal plains now rest beneath tens of meters of water. These drowned landscapes would have been among the most attractive habitats: mild climates, abundant fish, edible seaweeds, and migratory seabirds. If humans were present, their campsites, tools, and footprints now lie buried in sediments beyond the easy reach of archaeologists. The seabed is our greatest missing archive. Modern technology allows glimpses, sonar scans, underwater cores, occasionally a lucky dredge. But systematic exploration requires resources and long-term commitment. Until then, the most critical pages of this story remain submerged. It is not only geography that silences the past, but also the fragility of the record itself. Organic remains decay. Tools can be mistaken for natural stones. DNA dissolves in warm soils. Every successful find is in truth a statistical miracle. That realization shifts perspective. The story we tell is not the total story, but the rare survivor of countless vanished traces. For every tusk bearing cut marks or footprint layer preserved in gypsum, how many others have disappeared without leaving a trace? The human past is not a full archive waiting to be opened. It is a scattering of burned pages, and part of the challenge is learning to read what is missing. This awareness fosters humility. For much of the 20th century, there was a tendency to tell prehistory in confident strokes. Clovis first, neat corridors, single migrations. But the last generation of research has shown the danger of certainty. The more data we gather, the more tangled the picture becomes. Instead of one clear answer, we are confronted with branching paths, ghost populations, overlapping traditions, and timelines that refuse to align. To some, this looks like confusion. To others, it is a truer reflection of what humanity has always been: diverse, dynamic, unpredictable. So what still keeps archaeologists awake at night? It is the possibility that tomorrow a new site, a single tool or bone, could shift the story again. It is the realization that whole migrations may have left no genetic legacy, that entire cultures may be invisible to our methods. It is the knowledge that we may never recover the words spoken, the songs sung, the beliefs held by those first peoples. And yet, this is also what makes the work so compelling. Mystery is not an obstacle, but the essence of the pursuit. When we speak of the earliest Americans, then, we're not only speaking of ancient wanderers, we are also speaking of ourselves, the way we seek to know, the way we confront uncertainty, the way we live with questions that may never resolve. To hold that tension is not to diminish science, but to honour it. And as with so many human stories, the unknown is not a weakness. It is the invitation that keeps us searching, digging, sequencing, diving, and imagining. The haunting question is not when the story will end, but how far we are willing to follow it into the dark. Thank you, fellow sapiens, for wandering this timeline with me, for drifting into deep time, for slowing down and remembering. If this helped you fall asleep, helped you study, or simply helped you step out of the noise for a while, thank you for being here. If you think more people should know this story, you know what to do. Like, subscribe, share it with the sapiens in your life, and tell me, are you listening before bed, while working, or somewhere in the world I can only imagine? And as always, stay curious, stay calm. I'll see you in the next story.